GPTP, Generic Precision Time Protocol, and we also have Stream Reservation Protocol, Scheduled Traffic, Frame Preemption, Forwarding and Queuing of time-sensitive streams, to name a few. For AVB, we have implemented protocols such as AVTP as well as AVDEC, and there's also Milan 1.1a. So these protocol stacks, they run in standalone user spaces for Linux, as well as dedicated threads for FreeRTOS as well as Zephyr OS. So we have included in this stack multiple reference applications, which illustrates AVB as well as TSN use cases. It is important to note that this software stack, it relies on TSN functionality, which is implemented by dedicated hardware, Ethernet hardware controllers. So I'd like to move on to how this stack is used in different applications. So some of the uh, targeted applications for this stack are industrial, consumer, as well as automotive. So in the AVB technology, there has been an increased focus for a stack on audio video streaming applications, such as speakers, microphones, media servers, etc. While the TSN technology, it's focused on industrial endpoint. For example, as you can see here in the image, it's an assembly line with robots, server drivers, motors, etc. And this stack helps you implement this TSN technology um, because it provides higher reliability as it reduces the packet loss and it also minimizes the latency. However, the AVB standards, they help with time synchronized low latency streaming services, which you can use existing Ethernet based networks to use both your AVB as well as TSN technology standards. So after I've explained about how the GenAVB TSN stack has come into picture and what are the targeted applications that for the stack followed by the features, I would like to now talk about how this stack is basically integrated into different operating systems. And for this, I'll like to start with, what is this GenAVB TSN stack and what does it consist of? So this is a very simplified diagram of the stack that has been developed over 10 years. So the stack consists of an OS abstraction layer, which helps access the different operating system services such as kernels, drivers, and middleware. And it consists of a public API, which allows the application layer to access the stack. The public API consists of control API as well as the data API, and it also the stack also consists of protocols such as which includes the TSN protocols as well as the AVB protocols. So how is this stack implemented into Linux operating system? For this, I'd like to explain with a diagram that I have included here on this slide. I would like to divide the diagram into three major components. One is the application layer. The next is the GenAVB TSN stack, followed by the board support package. So as you can see, the protocol stack, it runs on the user space. And we also have implemented an AVB kernel module in the kernel space, the reason for which I'll explain in the later slide. We have used the Linux kernel with a preempt RT patch. The application gets access to the GenAVB TSN stack using a dedicated library called GenAVB TSN library. And the protocol stack accesses also the different drivers in the kernel space. So this GenAVB TSN stack is distributed as part of NXP real-time edge Yocto distribution, and it uses a BSD3 and a GPL v2 license, and it runs on a Cortex-A device. Some of the supported devices include i.MX, 8M Mini, i.MX, 8M Plus, etc. So how is the stack implemented in FreeRTOS OS? I'd like to again explain with a diagram and divide it into four components. One is the application layer. The next is the Genevieve TSN stack, followed by the MCU Expresso software development kit, as well as the FreeRTOS kernel. So the application layer accesses, as well as the protocol stack, they access the kernel using an RTOS abstraction layer. As you can see, the application layer has direct access to the SDK drivers as well as the middleware. Now, this stack is distributed with the NXP MCU Expresso software development kit. It uses BSD3 license and it runs on Cortex M. Some of the supported devices include RT1170, RT1180, etc. Now, how have we implemented the stack into Zephyr operating system? I like to again explain this with a diagram. So we have included an application layer um, and a protocol stack, as well as RTOS abstraction layer in the Genevieve TSN stack. So the stack basically accesses the kernel through an RTOS abstraction layer, while the Zephyr OS is able to access the software development kit drivers using a hardware abstraction layer developed in NXP. And here you can see that the protocol stack directly accesses the SDK drivers by bypassing the Zephyr device layer. So in Zephyr OS, the stack has been distributed with an XP real-time Edge Yocto with a BSD3 license, and it runs on Cortex A device under hypervisor. So this is a very special case where the Zephyr OS roadmap for microcontrollers is still in operation. So currently, we run the Zephyr on Cortex A using Jailhouse hypervisor. Some of the supported devices include IMX8M Mini and IMX8M Plus. So where can you find the stack?
Sorry,
Yeah.
I have a quick question. If you can, on the stacks, can you go back to the Linux stack?
Yes.
I just have one quick question. Yeah, this one. So I'm curious, you have AVB kernel module in parallel to the Linux networking stack. What is the purpose of that? Wouldn't the AVB just use the same networking stack?
As I had explained, I have included in the later slide with the challenges. So is it okay if I explain then?
Yes, that's fine.
Yeah, so I will be, yeah. So I'll be explaining much later why we had to do this. Yeah.
I'm just curious quickly. I have an IMX 8MQ that has Cortex M7 inside the SoC. I assume there's no reason that couldn't run this software on the M7 within the IMX 8.
So I'm sorry to interrupt, but I'll be doing a Q&A session at the end. Is it okay if I
sure.
can continue, and then in the end you can definitely ask your questions. Yeah, just so that I do not break the presentation. Yeah. So I'll be doing a Q&A session, and I hope to answer all of your questions. So now, as I've explained about how we have implemented the stack into different operating system, I'll now like to indicate where you can find the stack. So all of this stack you can find in the source form with different open source license on GitHub, and we will soon release the MCU FreeRTOS applications. And the NXP provides different SoC software enablement software distributions, and I've provided the links here that you can see, as well as the Harpoon, which is basically a base enablement software, which helps run real-time operating systems such as Zephyr as well as FreeRTOS as a guest OS on a Cortex A device. So as I talked about how we kind of implemented the stack into different operating system, I'd like to now move into how we have used this stack for different applications using some examples that we developed in our team. So to kind of explain better the applications, I would like to define some keywords that are important to get a better understanding of the application. Some of the keywords include, for example, a controller refers to a servo controller that runs high-level algorithms to generate motion profile for the motor. An IO device refers to a servo driver that directly connects to the motor, and it applies the control technique in order to control the motor. When I refer to a TSN endpoint, I refer to a hardware that can send and receive packets. It complies to TSN requirements and it helps terminate the network protocols. TSN endpoint here can act as a controller or as an IO device. TSN bridge refers to a hardware that can send and receive packets complying to TSN requirements, and it helps bridge the network protocols. While when I refer to an AVB endpoint, I refer to hardware that can act as an AVB listener or an AVB talker, and it helps terminate the networking protocols. So I'll move on to the applications that we developed in our team. The first industrial application that I'd like to mention here is a distributed motor control application, wherein where we built a TSN solution using a concurrent background traffic. So in this application, we used three TSN endpoints. One of the TSN endpoint acts as a controller, while the two other TSN endpoints act as the IO device, while we used three TSN bridges. So the objective of this application was to demonstrate generic precision time protocol to ensure time synchronization over the network, and also QBV, which is to ensure that we have dedicated time slots for networking traffic queues. While LS1028A, RT1170 were the devices that were used. I'd like to explain further with a video demonstration. So here we see two motors that operate with interlace strategy, and we have synchronized them over the network. So these two motors are connected to a TSN endpoint, which acts as an input-output device, while you can see the statistics that we were able to generate using this demo. To explain further, I will be indicating with a block diagram in further slides. So many industrial use cases, they involve cyclic isochronous exchanges over the network. So imagine that you're in a factory floor with multiple motors, robots, programming logic controllers, and you would like to synchronize the large amounts of data that is transmitted over this network. So in this TSN application, we implemented a control loop, which is similar to industrial use case. And all the TSN endpoints that have been implemented in this using in this application are synchronized to a common time grid in the GPTP domain, and they can send and receive traffic in a cyclic isochronous manner. And using GPTP, we are able to synchronize all the clocks in the devices. And if you'd like to know more, I have also indicated in this diagram about the control loops with two IO devices and a controller, wherein the controller sends commands to the IO devices while the IO devices sends feedback, and all of these messages are synchronized in the network. So a TSN endpoint in this application, it basically runs on a synchronized GPTP time with a 100 microsecond period. And the controller and the IO devices were scheduled with a half cycle offset in order to reduce the processing latency. The time sensitive traffic is a layer 2 multicast with VLAN header and a proprietary ether type. And on transmit, the QBV is used to send time sensitive traffic at a very precise time. I'd like to explain further with a block diagram where you can see the different network traffic. The controller sends the torque information to the I/O devices, while the I/O devices send back the motor feedback, which consists of the position as well as the speed of the motor back to the controller. And because of TSN technology, we were able to synchronize all of these devices using over the network using various protocols such as GPTP. And QBV was helping us to schedule the traffic over the different network ports on transmit. And using TSN technology, we were able to ensure that the critical traffic was able to reach its destination on time, even in the presence of concurrent background traffic, which was generated using a traffic generator. So in this example, you can see that we have used uh, three TSN endpoints, a controller and I/O device, which run on RT1170, which act as, which is a Cortex-M device running where our stack was implemented on a FreeRTOS operating system, while LS1028 is a Cortex-A device, which we implemented using, which we implemented our stack using Linux operating system. So another I'll move on to another application which also demonstrates TSN technology. And here I would like to show you a robot machine interface for machine inspection. So in this demonstration, uh, we used a robotic arm, which is controlled using both real-time image detection as well as a TSN technology. So a camera is basically connected to an IMX8M Plus board, which is a Cortex-A device, and it detects the Apple images. And this device also acts as a controller to send control commands to the input-output device. And the robotic arm is connected to an input-output device. While the LS2028, which is a Cortex-A device, it acts as a TSN bridge, which helps bridge the network protocols. And this demonstration was used to uh, show a GPTP protocol as well as QBV over the network, quite similar to the application that I showed earlier. While you can see the tablet basically simulates a conveyor belt, it consists of a small web game which shows multiple um, images, fruit images. And the objective is once the controller, which consists of, which contains both the image detection software as well as the TSN stack, it once it detects the Apple images, the robotic arm has to go and click on these images on the tablet. I like to demonstrate this further using this video. As you can see, the robotic arm clicks on the Apple images. And to explain further, I like to indicate the example with diagram, wherein we have two TSN endpoints as well as one TSN bridge. And what we had done was we had used the IO device implemented on a Cortex-M device and using FreeRTOS operating system, while our Genevieve TSN stack was implemented on an IMX8M Plus over a Linux operating system, as well as on the LS1028, which is a Cortex A device. Our stack was implemented on Linux operating system. And all of these devices are again synchronized over GPTP time, and QBV was enabled on all the networking ports. So in this demonstration also, we used TSN technology to synchronize data over the network, while the controller sends control commands such as talk to the IO device, and the IO device sends the feedback, which consists of the speed as well as the position of the robotic arm back to the controller. So this is again another demonstration of TSN technology. While I focused more on the TSN, we also have the image detection technology that used in that demo. So now I'll move on to another interesting application. Um, so imagine that you're in a recording studio and you have multiple microphones as well as speakers, and you would like to synchronize the audio that is rendered on the speakers. So to do this demonstration, we used two AVB endpoints which act as AVB listeners, while one AVB endpoint which acts as the AVB talker. And we used an AVB bridge to bridge the protocols. So this demo actually was used to demonstrate two important protocols in AVB. One was IEEE 802.1 AS as well as 802.1 QAV, grid-based shaping protocol. And to explain further, I'd like to use this block diagram. So the microphone is connected to the talker AVB endpoint, and the talker basically sends AVTP streams over the network to both the listener to the two AVB endpoints which act as listeners. So the objective was to ensure that the audio that is rendered on the listener is time synchronized. That is, we're able to listen to both of them at the same time. So for this application, we used an IMX 8M Plus device as a talker, which is a Cortex A device, and we used implemented our stack over Zephyr operating system using Jailhouse hypervisor. While for the listener devices, we used an RT1170 device, which is basically using Cortex M, and our stack was implemented on FreeRTOS operating system. While for the bridge, again, we used a Cortex A device, and our stack was implemented on a Linux operating system. So all of these devices are again synchronized using GPTP protocol, and various other protocols are involved in ensuring that the audio streams reach their destination on time. So now, after I have talked about the stack, the features, how we have integrated into different operating system, as well as some of the applications that we implemented using the stack, now I'll move on to some of the challenges that we resolved in this GenAVB TSN stack. So some of the challenges that we have encountered when we used a Linux operating system was we had a high network packet processing overhead, which impacted the overall performance of the system. For example, because of using the Linux protocol stack with the Linux networking stack was leading to high packet processing overhead, we created our own AVB kernel module that can bypass the Linux networking stack. And we observed that this greatly improved the performance and helped us reduce the latency. For TSN applications, we used AFXDP sockets, and this was again used to bypass reduce the Linux networking stack processing overhead. So I have indicated this using the data paths in this diagram. So I hope this answers one of your question about why we used AVB kernel module. And I'll move on to the next challenge that we faced was if you're going to use, if you require for application a very high resource intensive device such as a Cortex A, um, this can affect you because if you want to use a Linux OS on a Cortex A, because of the high packet processing overhead, some of the real-time applications, such as a motor control application, cannot be implemented. So for this, our solution was basically to use a hypervisor. So we implemented a FreeRTOS or Zephyr running on a Cortex A, and which can handle the critical data paths using a jailhouse supervisor. So the jailhouse basically helps us partition the physical hardware to run both Linux as well as the guest FreeRTOS or Zephyr RTOS in parallel. In terms of implementation of this stack over microcontrollers, uh, as we all know, we had limitations both in memory as well as CPU resources. So for this, we had to carefully partition the code and the data into very specific memory region. For example, we used TCM memory which is closer to the core for storing our critical data, and the other memory such as OC RAM for non-critical data. While we also did dynamic allocation of resources and heap, tailored for very specific use cases. While to smoothen our CPU load per memory utilization, we made a hard limit on the number of packets that can be processed per unit time. So these were some of the challenges that we encountered and how we had resolved them. And if you would like to use the stack for your own applications, do let us know. I'd like to conclude my slide now, and by saying that um, if you're interested in using our stack, then do visit us on GitHub. And if you'd like to propose some changes, also you can refer to our GitHub and let us know. Your comments, yeah, will be open. And now I'll like to move on to the questions that you might have. Thank you. Yeah.
Nice. Thank you very much, by the way. I think this was very informative, and I think that this stack will be very useful to many people. I often hear people needing a stack for AVB and TSN as it's becoming more and more used. Following up on your the stack question that I talked before, maybe a little. Now I understand. Did you try using AFXDP instead of the other block for the data plane, or for AVB as well as TSN, or was there an issue with that?
Sorry, I'm kind of lost because of the. Yeah. So you asked if we have tried using AFXDP for our Linux
Yeah. So
operating
you
system.
said for TSN you used AFXDP for the data plane to bypass to get better latency.
Yes.
And you could use the same thing for AVB, correct?
This is a bit more like the architecture part of the question. So probably I would not be able to answer this. Probably I can get back to you in email, and you
Okay,
can refer
no
to me.
problem, no problem. I
But
was just
yeah,
kind of
yeah,
curious, but yeah, okay,
yeah.
no, it's a
I
pretty
would
good
like to
presentation.
not make a mistake in the architecture part. So probably why we would not used it for specific AVB. So to make it clear, the AVB kernel module was not only for AVB application, but it was also for some other specific use cases, which I have not detailed here.
I
So
see.
even though it's called AVB kernel model, it's not only for AVB. Though I kind of wrote for AVB here. Yeah, it kind of
I see.
simplified it a
I
lot.
see.
Yeah,
Yeah. Okay.
yeah.
Okay. Interesting. Yeah. Thank
But
you
if
very
you would
much.
like to know more about the architecture, probably I can respond to you more in email. Yeah,
Okay. Yeah, I'd love to follow up later, but thank you.
yeah. Thank you.
Yeah.
Any other questions?
Yeah, I was just curious if you, in the IMX8 SoC, you have Cortex M7 cores on a lot of them, and you're talking about running on processors that are standalone Cortex M, but is there any reason you couldn't use the Cortex M inside the IMX8 SoC to run this stack instead of running it on the Cortex A core?
So I was referring to those devices where we wanted to use Cortex A core. So this was just an example. And we have not extended our support. If you're being specific to Zephyr, if I'm not wrong.
Well, if we could run FreeRTOS or Zephyr on the Cortex M7 inside the IMX8 SoC, and we could run Linux as a controller, say, or run some other application on the Cortex A, if the Gen AVB stack were actually running on the Cortex M7 at the same time. I don't see why that wouldn't work, but that's the question.
If I'm not making a mistake, the 8M Plus only consists of a Cortex A device.
I have an
I'm not
8MQ, so my 8MQ.
MQ. Okay. So if you notice, I have not mentioned 8MQ in my So we have only
That's why I'm
support for
asking.
us. So, yeah, so we have only support for specific devices. So we have kind of tuned the stack as well as the software. We only support for certain devices.
So
So that
yeah.
if you want to provide support for new hardware, we will we'll have to enable it.
So
So
maybe the kernel
the
module would need to be modified for the 8MQ?
yes, yes. We'll have to, if you notice, we'll have to change the driver part, and yeah, I'm just going to the part where I had talked about the yeah. So if it's CEFI, then it will involve changes in the HAL as well as the driver layer, and if it is FIATOS, yes, the kernel part and the drivers and the middleware have to change. So we'll have to work on it to support new hardware.
Thanks.
Any other questions?
This is
Yes, I already downloaded it.
this. Can you pass on the mic? Yeah.
And how do we access the slides from the presentation?
I have put this presentation slides on the schedule, embedded open source schedule.com, I guess. It's open to access. I've already uploaded it like on Monday. And if you would like me to send it to you, also I can send it to you. You can,
I'll look at the schedule.
yes.
This is from YouTube. Why is there a special module inside the Linux kernel to support AVP/TSN? Why do you not extend the Linux network stack with the new QoS?
For this, I think I talked about the processing overhead. But if you would like to know more the architecture details, then probably I could respond to you by email.
Okay, great. Thank you. I think that's it.
Thank you.
Thank you.
So I would also like some feedback. I mean, would you about the session? So feel free to.
I found this interesting and informative, so thanks for your presentation.
Thank you. Yeah. Is any other questions?
I think it was very informative, and as you saw from, there's probably some follow-up questions. You had there's a way to reach you by email in the slides.
Yes. So I'll probably go to the first slide. I'm sorry, this was not an architecture presentation, so I didn't go in detail. Yeah.
It's hard
so
to
probably
cover.
you can reach out to me email. Yeah.
Yeah, okay. I just for other people online, that makes sense. Yeah, no, it's hard to cover everything at all depths in an hour, so it's okay. Thanks for letting everybody know about it.
So you can find my email here, and yeah, do look into the slides that I've uploaded on the sked.com. Yeah.
Great. Thank you, Manasa.
Thank you. Thank you.
Hey, good morning, Dimitri. We're dialing the live streaming in on our end. If you're able to share slides and all that, we can get everything configured and ready to go.
Just you can hear me.
Hey,
Well,
yes, we can hear you.
okay, yeah. Hi.
Hey, there it
Okay,
is.
I have showed them.
Perfect, looking good. Give us a couple seconds to configure it on our end. So that's looking great there. And your audio sounds great. So you're on for the 9:55 time slot, right? So it looks
Yes,
like
I think so.
perfect. So we've got about 6 minutes here. We'll probably put ourselves on mute. You can keep everything shared and up there, and then we'll pop on and let you know when we're good to go, and then you can start right into your presentation.
Okay, that's good. Thanks a lot.
Perfect.
Okay, hello everyone. Uh, my, my name is Dmitry. I'm a kernel contributor since 2007. I'm currently working at Linaro. I'm co-maintaining one of the drivers in the DRAM subsystem. I'm constantly reviewing drivers inside the Qualcomm ecosystem. And this, one of the questions that constantly arrive both during my work, during my spare time, and during the reviews is how to get this vendor driver, that driver written by the hardware vendor or by some other company, how to get it into the kernel. So during the slides, I will use a small convention. So if it is minus, it is a bad practice. If it is plus, it is best current practice, as far as I know. And if it is written in current U in the monotype font, it is a command to run during your work. So upstreaming the vendor drivers, upstreaming the drivers at all. Why do we care? We have an existing driver for our important device. Let's keep it out for ourselves. Let's keep it out of tree and never send it upstream. And if the user is interested, they can come and use it, isn't it? Oh, it's usually not good enough. It's not important enough, really. Nobody cares. So why should we send it at all? We can maintain it ourselves. We don't need any help. But more importantly, we can get excited. We can break some rules. We can change the API. We don't care about all the upstream conventions. So rules do not apply to us. So we can do whatever we want. Sounds good, but that's not the whole story. So keeping the driver, keeping the code outside of the mainline tree has a huge maintenance burden. Kernel developers are constantly changing the API, they're doing it. Breaking the user space API means breaking assumption of the existing software. And if you are not in the upstream, you cannot really follow the API and ABI of the platform. And also, last but not least, if the maintainers, in particular, one very known maintainer doesn't see interest in this pattern code, these can easily get dropped, and now you have not only to maintain your original driver, but also the whole platform out of tree. So it is quite frequent to see that when the vendor publishes some driver, it becomes abandonware, it doesn't satisfy users, it is forgotten after being published. And this is why frequently we end up with some old code from the vendor and our wish to upstream the driver, our wish to send it to the kernel. A side story or an additional view, what if we have a whole kernel tree, like we frequently have in the Android use case? Can we just keep using it until the device is done? Well, frequently software dies or gets out of scope quicker than the hardware dies. So you are left with the old tree that is like several years ago, but still you want to use this phone, this tablet, this television, etc. And still all the issues of the maintenance burden apply, but they are multiplied by several times because you are not only have the driver, but you have the whole API, the whole kernel to keep and to update, to apply security fixes, etc. So this was actually the story that brought me to the Linux kernel because I wanted to make Linux kernel support some of the devices that I wanted to use on a daily basis. And this is what drives my day-to-day work. So let's get this driver and let's send it to the upstream kernel. Initially, I thought that it can be this session can be a set of harmful advices from my side as a maintainer, but I felt like it is a bad way to go. So it will contain some harmful advices, but they will be specially marked as that. So attempt 1, we have our fine a driver written for the important device by the famous vendor. It should be ready. It should be good to go. It has been tested. It has been used on a variety of devices. So let's send it as is. It should be accepted. It is good. Oh, not really. The kernel maintenance and the whole kernel story is about maintaining code written by others. So the main question is not if the driver is good, but the main question frequently asked by the kernel maintainers is, can we really maintain it? Does it follow Linux code style? And those are the questions that you should ask yourself before sending it. Does your driver follow Linux code style? Does it use spaghetti code, as it's frequently seen in a different code environments? Does it use spaghetti code? Is it full of if-defs and all the ifs, all the hell of indentation, all nested loops and nested conditions? Does it has huge functions that nobody can understand? If it is the case, then you should rewrite it. Follow the coding style, use the check patch, use the tools that are provided to you, and take a look around. Look what is expected. Next point, next question: does it really compile? Well, it surely compiles on your system in your case. But what about different architectures, different NDNS? Most probably you know about x86 and ARM. What about, can it be compiled on MIPS? Because distros or some maintainers will try compiling it there, and it shouldn't break. Does the code generate any warnings when compiled? Well, if it does, you should fix it. Does your code generate any warnings if you compile with additional warnings enabled? And if so, you should fix those warnings too. So that's good. Well, still not enough. What about the driver itself? Will it behave? Will it crash if there is no hardware, for example? Or if there is no memory? Or if any of the resources get taken from under it? What if the user sends the wrong command or the wrong IOCTL? What if the firmware or the actual hardware sends wrong data to you? Will it spam logs? Will it crash? Will it do anything else nasty? Well, if it does, you should fix that too. And think about somebody trying to break your piece of code or your hardware, and fix all those issues. Okay, so you have written the code, you think that it is good. Can you send it? Still not yet. We should prepare the patches for the upstream. You should try to follow the upstream development process. I will spend some time on it a little bit later, but the current suggestion is to use the before tool written by one of the kernel developers, because it significantly simplifies the life of the patch set. It significantly simplifies the use of the setup of the system, and it tracks what you have sent. It tells you that you are not ready to send a new version, or you should write the change log, you should write some data about it, etc. And the first question that even before tool asks you, before you start the patch set, what is the baseline? Where should you branch your branch from? And we have seen several different responses to this question. We have seen this in the actual patches being sent to the for the review. We have been testing this with the last year a long-term support kernel. Or yeah, this is a huge patch set that was based and that was tested on 5.15 kernel. Yeah. So these kernels are way too old. As I said, kernel API changes, and we know that there is no such thing as stable API in Linux kernel. So if you are looking for the place to start your to use as a baseline, please use Linux next. Or in some cases, you can use a Linux tree, but there can be issues and maintainers can ask you to rebase later. And just use before to start your branch. Apply all your patches, commit them, and now think if the driver is complete. Did you document your public API? Did you document what you have added to the kernel? If it is a device tree-based platform, which most of the embedded devices are, did you document the device tree additions? There were several good talks by one of my colleagues, Krzysztof, that are dedicated to device tree handling, so I will not be spending more time on this. But if you are touching device tree or if you are using any of the device tree properties in your driver, you have to document them. You have to make sure that your schema checks pass and that the device tree files that you are generating do not generate new warnings. Last but not least, you have written, you have committed everything, you have documented. Now, as it is usually said, well, take a step back, take another look around. Does your driver actually fit what is going on in the rest of the system? Take a look at the mailing lists, read what's going on, because it well might be that you are trying to send the driver and the first response will be, oh, please wait, because we are going to rewrite this part of the subsystem. Oh, yeah, so check similar drivers, check similar code, and be prepared to rewrite that part. Last but not least, think about splitting your patch set. During the last year, we have seen patch sets of several hundreds of kilolines of code being sent for the review. We have seen series of 30 to 40 patches just also being sent for review. Just, oh, yeah, this is a good driver written by us. Please take a look. Consider how much effort does it take for the maintainer to actually read those 30 patches and those hundreds lines of code and to understand it. And especially the case oh, yeah, by the way, we are adding the make file only in the last patch. And we are adding the patches file just one by one. So this was one particular case where we asked, please change the way you structure your code. We have seen different cases. So, oh yeah, by the way, this is the patch which is required to fix changes from another patch. Please do not do such things. So after each commit, after each patch, your kernel should build. The kernel should completely work. It should be possible to review all the changes. It should not require significant amount of going through those kilolines of code just to understand your work. Think whether you can split your patch sets. Think whether you can submit the code in batches. Every time, think whether the change, whether the patch set itself is logical, whether it is atomic, whether it does not depend on anything that you want to send in the future, and leave no gaps that should be fixed in the future. Yeah, so it is ready. A lot of people come from a different ecosystem. So what about opening the merge request? I see Linux tree on GitHub or on GitLab. Or maybe there is a Gerrit. Can I send it in this way? Well, no. Neither you can send zip with all the patches. And believe me, all this can sound funny, but I have seen a zip file with patches like, I think, a week ago, being sent for one of the trees. So The Linux kernel uses a mail-based subsystem, a mail-based submission system, no exceptions, no pull requests, no merge requests, no GitHub, just email. And again, before tool is pretty helpful here to organize the patches and to organize the whole thread, because it makes sure that the patch set gets a cover letter. It makes you write that cover letter. It makes you describe your changes. And it makes sure that everything is sent as a single batch. It well might be that your corporate firewall does not allow you to send emails, or if it does not allow you to send emails other than through the Outlook or any other strange way. Now, before can do that for you too. It requires additional configuration, but it can be done. And so it leverages a significant burden from the patch senders and patch authors. So you are finally ready to write before send. You hit the enter, and now what? During my first submissions, I was really eager to see any reaction, and why don't everybody respond in just an hour or in 2 hours? Well, I was a kid at that time, so wait for the feedback. Let maintainers, let reviewers, let everybody from the community take a look. So it can take days. In some obscure cases, it can take more than a day or more than 2 days. Networking subsystem has a rule that all the patches should be responded within 2 days. Other subsystems do not have such rules, so it can take up to weeks. So you got some feedback, and now comes the hardware advices that I promised you. And they actually come from the experience on the mailing lists and from the patch authors. Oh, let's ignore maintainer's comments. Why should I bother? He doesn't know my hardware, he doesn't know my device. Let's skip some of the maintainer's questions. I will answer most of them, but I do not or I cannot answer this one, so I will just silently skip it. Oh, I don't understand the question. Well, English is not my native language, and it is not a maintainer's native language, so we just cannot communicate. I will ignore him. He has to accept my patch anyway. Or even worse. Oh, yeah, I got this single line of command. Let's send the new patch, the new iteration immediately. I'm so excited. Yeah, you are, but the maintainers are not. The first rule of thumb is to discuss your changes. You have to, well, you don't have to agree, but you have to provide some questions. You have to describe why you are doing it this way, and you have to come to the conclusion before sending new iteration. So you have understood some of the points by maintainers. You got him. You got it. You agreed with him. So you want to implement new changes, but before you are doing that, well, most likely reviewers have responded with some tags and with some trailers. They wrote that, yeah, the patch was reviewed by, it was act, etc. And it is quite frequent, and I sometimes do that too, is to forget to pick up those changes. That was pretty hard to do before the before tool, but now it is as easy as to say before trailers minus u, and it will pick up all the trailers, all the tags, all the information that maintainers have added to your patch set, and it will keep it forever. So yeah, do it, implement the changes, commit, edit the cover letter, describe the changelog, describe what you did. It is one of the frequent points that we see, oh, implemented all the comments or fixed all the comments. No, that is not enough, because when I start reviewing your patch, I want to understand what you exactly did. And thus, you have to describe your changes in the cover letter. And as I said, please, before sending a new iteration, give everybody time to review, respond, acknowledge, disagree, etc. The rule of thumb that should be adhered in 99% of cases, and if you're unsure, just follow this rule. There should be no more than one iteration in 24 hours. Never, never, ever. For a big patch set, give it several days or give it a week. If you see that there is a discussion still ongoing, it is better to wait rather than to spam everybody. Okay, so yeah, we are ready. Everybody has settled before send. Yeah, so what happens if it is actually a sad case when your patch set gets ignored? Well, the first thing to do in such case, so you haven't got any responses in like a week, check if you have followed the procedure. Are you trying to send the patch set during the merge window? Are you trying to send the patch set in a wrong time? Or did you actually add all the proper people and all the mailing lists that you should have added? Did you get all the maintainers as the targets? Beforehand, everybody was writing their own scripts or writing the tool lists for such things. Before can do that for you, but still, it is worth checking. But usually, if for some reason you did not get a response in 2 weeks, it is fine either to reiterate the series or just to ask on the mailing list. Yeah, ping the maintainer asking, yeah, what's going on, just as a response to your email. Because it well might be that something is on vacation or is busy with the other stuff. So resend the series, ask, and be prepared to wait again. And sometimes this can take a while. But hopefully and usually it gets picked and it gets reviewed and you get on the path. For the fast patch series especially, it can take some time to get everything done correctly. Please be attentive to the comments. It is an iterative process, both for you and for the maintainer. You should be improving your patch set each time. So don't worry if it is version 10. It is not so frequent, but it happens. Sometimes we see version 20. It shows, it can send different signals, but it's not, if nobody is telling you to stop at version 20, yeah, you can continue if you're improving your patch set. And in the end, if you don't stop, it will find the way into the kernel. The thing about vendor drivers, and as we are focusing vendor drivers, be prepared to rewrite it. Be prepared for the complete rewrite or even redesign of the driver, because it is quite frequent that original authors of the driver had their own requirements. They had different kernel versions, etc., and the kernel had improved in those years. So it might take a while. Don't think that it takes too long. Please be motivated to do this work. It is both nice experience to you. It helps other people because it expands the Linux kernel, the variety of devices that Linux kernel supports. And it also significantly helps maintainers because we can better understand what are the needs for the subsystems, what are the needs, what do you need, or what other drivers and what other devices need from the core subsystems. Last but not least, especially in the commercial development, we are frequently asked, oh, can you do this, or can you upstream this driver by this deadline? And frequent and constant answer is, we do not know. So be prepared to lose all the hopes, all the deadlines, all the estimates when you submit the first iteration of your patch. Because sometimes you can estimate, oh yeah, this is a simple change, this is a single line iteration, so it will be there in 2 months and 3 months. If it is more than that, it the process can take a while. So it will be a while when somebody else can actually download the kernel from the distribution or from Linux and use it on his device out of the box. But it all pays. It is all for the benefit of you, of the driver, of hardware support, and of, more importantly, of other users of the subsystem. And the thing that I do not stop reiterating over and over, and which I keep on telling other people, especially when they're new to the Linux kernel development, it is better to ask a question rather than to show the ignorance. It can take a while for the maintainers, for other developers to answer your question. But it is much worse if you just ignore what is going on and do the thing as you think it should be done. Sometimes you might be right, but in this case, you are most likely you will not be most likely listen to this presentation. So if you don't get the question, if you do not agree with the maintainers, in 80% of the cases, you are not completely correct. Few links, kernel documentation, Git manual, important Git trees that you should know before sending the patches or before working on the patches. And that's all. Thank you for listening. This presentation was driven by, or this lecture was driven by seeing other people and other vendors trying to upstream their code, and by trying to pinpoint in a single reference way all the possible mistakes that you can do, and how to cope with them, how to not to do them, and how to be cooperative. I would really like to hear failure stories, success stories from you, what we as the kernel developers can improve, and what was done incorrectly from our side. And I hope to see your patches on the mailing list. I hope to review them, especially if they are in the DRAM, in the DRAM, so in the graphics or in the Qualcomm side. So thank you. That's all.
Great. Does anybody have any questions?
Hi, I'm part of a just volunteer community, kind of like working to build some drivers for Pine 64 software. Have you noticed any kind of unique challenges that are faced by these kind of often not very professional developers who aren't, they're doing it on their volunteer time when they try to upstream these drivers that they've written?
So yeah, this is an interesting question. So we often see a significant part of the kernel contribution done by the companies. I mean, Linaro, our company, Red Hat, other big vendors. But you will always see the line unknown or others in the LWN statistics. So last year, I actually made a case. I computed amount of changes done for the DRM MSM driver, so the kernel display for the Qualcomm device, for the Qualcomm platforms driver, and I computed how many changes were done by the companies and how many changes were done by the volunteers, and 1/3 of all the changes that actually landed to the kernel were done by the volunteers. So I would not call them, excuse me, so this is a pretty long answer. I would not call them unprofessional or amateurs or anything like that. In most of the cases, on a significant amount of cases, the patches from the volunteers are of a much better quality, because they don't have companies staying behind them and pressuring them. So they the volunteers are tuned to learn. The volunteers are ready to that it will take some time, and they work on improving their patches. For some obscure, for all systems, it takes years, and we still see patches going from like for the platform that is 10 years ago. So I have seen some of the patches sent for the Pine 64, and I cannot say that they were done in some unprofessional way. So just please keep going. Please work with the corresponding maintainers, with the developers that are in charge of the subsystems, and you can do it.
Thanks.
If you have any particular question about any particular case, feel free to ask. But in general, there is nothing wrong and nothing bad. And volunteers they are not the core, because most of the core developers end up being paid. But volunteers is our driving force, because in the end, everything that we are doing is done for the users, not for our own sake. Yeah.
Okay. Anybody else?
Any more questions?
I think that's it, Dimitri. Thank you.
Yeah, thank you. And if you have any further questions, please feel free to use the email to ping me in the spare time. If you need professional services from Linaro, please feel free to ping our contacts, and we can do that for you. Yeah, so thank you for listening, and have a nice rest of the day. Have a nice conference.
Testing, testing. All right, there we go. Probably a little higher for you, actually. Wow, this is really, yeah. How about you?
Let me turn mine on.
Okay. You might want to actually put it on your, yeah. Sorry?
Testing.
Go for it. Sorry, go for it.
Yeah, can you hear me? I don't think so.
No, well, maybe higher for you.
How about now?
Yeah, there you go. Okay. All right, cool. Boom. Bam. All right, here we go. From the back, you guys good to go? First to start? Sweet, perfect. Hi, everybody. Thank you very much for attending today's session. My name is Denny. I'm a developer advocate at Databricks, but the real person who actually knows what they're talking about is Ankit here, so we're going to have him do most of the conversations, actually. But we are here to talk today about DBRX, or DABRX. I'm trying to make that a thing, by the way, so I want you to start saying DABRX. We're always debating with each other, so there's some are saying DBRX, some are saying DBRX, but that sounds like a prescription, so I'm trying to avoid that one, so hence DABRX is the one we're going for, because that way I can toss away, I don't have any today, unfortunately, but I can toss away toy dinosaurs, because, you know, that's how we make things fun. Okay, we've got a lot of slides, but we want to make room for lots and lots of questions, okay, about how DBRX was built, why we're building it, the methodologies, the processes, things of that nature. And that's what we're going to go through today. And we're going to start right into the architecture. And again, we got somebody who actually knows what they're talking about right there instead of me, okay? But let me at least provide the basic principles in place first, okay? So what is DABRX, okay? It is our very own open source large language model, okay? Hopefully everybody here knows what an LLM is, yes? Yes? Okay, good. I just make sure. So I actually went to middle schools, and they actually already knew the answer, too, so that's actually pretty sweet. Okay, so just want to make sure. That's all, okay? All right, so we have the base version, which is our pre-trained model. Think of it like a smart autocomplete. That's not the one you're usually chatting with, but that's the one that you often will go fine-tune or do whatever else do you want to do with it, okay? But now, DBRX Instruct, that's the chat version of it, the fine-tuned version of the model, which is really good for the chat GPT style, like what we're all sort of used to doing, okay? It's designed to basically answer questions and follow instructions. It's built on top of, excuse me, on very domain-specific and fine-tuned instruction-following data. Okay, that's basically what every other Instruct or chat version of these models does. So not much difference there, okay? So if I'm going ahead and running, this is an animated GIF, and we have it actually on all of our blogs. But basically it just shows you running Llama 2 70B. Now, pause for that second. That's Llama 2, not Llama 3. Llama 3 was just dropped 9 a.m. this morning. Okay, it's a very, very fast and fast-moving system. Again, I'll have Ankit go ahead and cover it. So this is Llama 2 because we graded this demo 3 weeks ago. Okay, so sorry, we're not up to speed yet. Okay, but so right now, if you're running them side by side, it's extremely fast. In fact, within the Databricks platform, we're actually able to get 150 tokens per second, which is pretty sweet. But the key thing that we're calling out is that it's trying to find a balance between being extremely knowledgeable but also very fast. And that's actually what we're going to dive into a little bit with the architecture a bit, okay? So it outperforms many, not all, because Llama 3 just came out today. Mixtral 8x22b came out technically 2 days ago, I guess. The base actually was last week, so it's also very, very good, okay? But the open source models that we were able to talk about, for example, in terms of like Llama 2 70B or Mistral, this is the older version of it, Grok 1, it basically outperforms it for programming, for language understanding, for mathematics. Okay, and then you'll see benchmarks like MMLU or Human Eval, which is the worst name ever for a programming benchmark. Okay, or GSM-AK, which is basically the mathematics. Okay. This also, we've got more slides like this for basically for MLU. Again, just showcasing how we've helped build a model that is extremely good. And again, if you're going to ask me the question, hey, but how does Llama 3 do, or how does Mistral 8x22b does? No, they do better. Okay, this is not us trying to claim that we're always going to be king of the mountain. We were king of the mountain for what, 3 weeks? Maybe? Yeah, about 3 weeks. Okay, that's cool. In the GenAI space, that's pretty good. Okay. All right, we even outperformed ChatGPT 3.5. okay, which is pretty sweet. Okay, so that's what these numbers are showing. So this is just a quick radar plot showcasing, again, the older version of Mistral Instruct, Llama 2, again, 270B, and ChatGPT 3.5. And you notice that basically the bigger the plot, the more it can cover in terms of the different benchmarks. And that's exactly what DBRX was able to do, which is, again, really sweet. Okay, but now we're going to dive in a little bit in the architecture, and then boom, I think this is where Ankit will take over.
Awesome. Well, can everyone hear me okay? My name's Ankit. I'm one of the engineering leads at Databricks for what we're calling the Mosaic AI platform. And I'm super excited to talk about DABRX, DVRX, whatever we want to call it. It's an open source model. So I've been doing this for a while, and that counts as like 6 months, basically, in Gen AI. No, I'm kidding. I mean, we've been doing a lot in this space for a little bit around a year. But this space moves incredibly fast. Which is super, super exciting because it's kind of one of the moments of frontiers of a new technology, and every day almost it feels like something new or interesting is happening. And so we wanted to show a little bit about that, right? So like our friends at Mistral, which is a great company also producing open source models, put out this tweet actually a couple of days ago when they released their new model, Mixtral 8x22b. Since then, these models have all come out. And so, that's an insane amount of progress on the Pareto frontier of model quality versus cost. The model that we're really, really excited about today is Llama 3, 8B, and 70B, which are now available on our platform for folks to use. And they're extremely high quality. You might notice I had to expand the y-axis of this graph to cover Llama 3 70B. Which scores around 82 to 83% on MMLU. That's really awesome because that model is open source. Everyone can use it. The community can build on it. And that's what we already saw with Llama 2. Over the last year, thousands of model variants have emerged that are derivatives of Llama 2. And this is a story that's been told by open source for many years. And we see it play out in Gen AI as well. So today is actually a big day for open source LLMs. But we think that for enterprises to be successful with open source models, they need to customize it with their data. The product that I've built over the last year and a half actually helps enterprises deploy these models in their Gen AI applications. And it's still super early for everyone. Most folks are in the POC phase, and anyone who's in production is very likely using a closed source OpenAI model. So it's incumbent on us in the open source community and those of us who serve open source models to find a way to make enterprises successful so that they can actually leverage the open source. But in order for that to happen, the models they're serving need to be faster and still high quality. The differentiator there is data. And the nice thing about open source models is that they have open lineage and the data can be private to a company, so they can create a version of their own model that's based on the open source. So what is the point of us building DBRX? Why did we do that? We actually built it as a demonstration of our platform. We built the whole model on Databricks with Spark for data preparation, MLflow for experiment tracking, and LLM Foundry and Megablocks for training. These are all open source projects that Databricks has released and that are available natively in a vertically integrated way on our platform. And that end-to-end solution is actually what we provide to enterprises, which we call Mosaic AI. And what we showed with DBRX is that we're able to produce SOTA quality models from that. But like I said, right, the base model is not the game that we want to play. The game we want to play is actually making customers successful by fine-tuning or fully customizing that base model on their own with their data and their tokens. But we can first dive into the architecture. We did a lot of really interesting things there to actually make this model state-of-the-art quality. So it's still a transformer-based architecture. And there's a lot of technical terms here, but basically it's the same as all the other open source LLMs, right? It was created entirely from scratch by us. One thing I wanted to call out is it was actually pre-trained on publicly available online data sources. We did everything by the books here. No customer data was used to train DBRX. It was trained on 12 trillion tokens of carefully curated data. We didn't train on any tokens from any other quality language models. So this is pretty pure, and that's required for folks to actually be able to use open source. There can't be caveats in the license or caveats in the data that prevent people from using it. So we used a bunch of tricks here, including stuff like what we call curriculum learning, which involves basically at the last kind of stage of the model, teaching the model in a different way. And the model is able to support 32K tokens worth of context. Maybe just as a first check here, like raise your hand if you know exactly what a token is. So, like that's a good fraction of the crowd knows, but I'm just gonna define it anyway. A token is maybe like 3/4 of a word. And that's kind of a weird definition, right? But like, if you asked me if I knew what a token is, like I don't actually have a good intuitive sense of what it is. For example, ing is a token, but run is also a token. And so you can kind of think about like complex constructions of words as being 1 or 2 tokens. So you can treat it roughly as 1 token is 3/4 of a word. So what does it mean to have 32K tokens worth of context? It means that you can pass in a book to this model, and it's able to reason about that book and then give you an answer about that. That's super important for enterprises who are largely using these models to actually look up manuals or long pieces of data and then answer questions about them. We trained the model on 3,000 plus NVIDIA H100s. That's a big cluster. Pre-training, post-training, evaluation. The whole process took us around 3 months. So why is this model so interesting from an architectural point of view? It's because we actually used a different kind of model architecture called mixture of experts. And it's an open secret in the community that this is what OpenAI's GPT-4 is built on. What this means is that there's actually, you can kind of think about it as a lot of different sub-models. If you had a matrix, there's a lot of different blocks to that matrix. And so that means that there's 132 billion parameters worth of tokens, of weights. But when the model is running, only some of those experts are activated. And so only 36 billion parameters worth of those experts are activated. So it's not quite this way in practice, but in reality, the way you can think about it is 132 billion parameters worth of knowledge exists in this model, but only 36 billion, the right 36 billion is used at the time of inference. That's really, really important because it makes the model smarter, but still fast enough to actually be useful and interesting. One of the #1 things we've actually heard from our customers as we launched the model is like, wow, we love the speed. Because that's really what matters to the end user, in addition to quality. So yeah, there's some details here. We use 4 of the 16 experts. There's a lot of combinations. There's a bunch of technical details around the actual kinds of encodings and linear units we use. And these are pretty interesting as well. For folks who are interested in this area, definitely recommend diving into our white paper on the model, where we go really deep on like why we used gated linear units, grouped query attention, and things like that. And we use the tokenizer that we use, the thing that converts words into tokens. We use just the GPT-4 one because we want it to be easy for people to transition from closed source models to open source models.
Yeah, one thing also I wanted just to chime in real quick about that last point. A lot of this is based on the latest research, okay? Just as Ankit was calling out, like the latest research, like Gen AI is moving really, really fast, right? Well, a lot of it has to do with the research. So we're actually, one of the whole reasons why we have Mosaic research in the first place is because we're keeping up with the latest research to try to understand which set of research is actually applicable versus which set of research maybe we're going to need to let it cook a little bit more, okay? And so these are some of the latest pieces of research that we've merged in. And again, as each model comes out, Llama 3 just came out today, Mixtral came out 2 days ago, things of that nature, we're taking account of, okay, well, some of the research is really cool, some of the research might work out. For example, just to chime in one tiny bit, Mixtral was based on this idea of megablocks, a sparse MOE. Ankit's going to cover that out. Well, guess what? That is actually a Databricks project, right? So some of the latest research that we see that was really good, we've open sourced it, and we made it available for everybody to work with. So just want to chime that in real quick.
Yeah, and actually to riff on that, one additional thing that's really interesting in this community right now is that a lot of what used to be the case, which is that academia is producing interesting open results, is no longer the case in this community. And that's really unfortunate. but it's a consequence of massive amounts of compute being required to test any of these ideas at scale, right? I mean, like, look, those 3,072 NVIDIA H100s, that is an incredibly expensive cluster. And most other companies, like, are not actually publishing the results that they get at scale because their models are closed source. By open sourcing this model, we actually are showing people that, hey, ROPE and GLU and GQA, we tested these things. They actually really do work. And you should use those. And you need to, and in fact, they work at scale, which is not something that you get to see in academic papers, unfortunately. So let's dive a little bit into that. I'm not a part of the research team. I'm on the applied side, but I'm good friends with a lot of the research folks, and they did a really great job with this model. We have an open source library called Composer that we use for deep learning, and it's optimized for scalability so that you can get really, really good performance out of these GPUs. We have an open source project called Streaming Dataset, which allows us to really quickly stream the right batch elements into the actual GPU at the right time and then get rid of them so that we have minimal memory usage when we train the model. We combine that kind of a thing into this thing called LLM Foundry, which is a package that we basically kind of use that you can drop in. It's open source, and you can train on as many H100s as you have with that package. And finally, we evaluate the model with an evaluation gauntlet, which is also open source, and it's a library used for evaluating these models in a statistically equivalent way. So this is a really interesting area where everyone has their own numbers that they publish. The numbers that we publish are always derived from our open source evaluation framework so that everyone can reproduce them.
Yeah, so just again, to chime in and to provide some little bit of context. So when you talk about LM Gauntlet, we've got about 30 plus different benchmarks across 6 different categories that are put together. Versus, for example, the Hugging Face LM leaderboard, it's a composite of about 6 or 7 different benchmarks. It's okay, we're not trying to compete in this case, it's more about there's a lot of really good benchmarks out there. We want different levels of detail. Some folks prefer the Hugging Face one. Some prefer the Evaluation Gauntlet. Some people will just want to show MMLU, which is the most popular one because that's about language understanding. Nevertheless, this is not us knocking one or the other. Quite the opposite. There's so much out there. So trying to track it and make sense of it can be very difficult. And so again, that's part of the reason why the research team open sourced a lot of this stuff, so you can all validate, leverage, review, understand exactly what we're doing. Okay?
Yeah. And the key element that unites all of these things is that we have a really strong focus on performance. Without a strong focus on performance, open source models are not trainable by the community because it takes too long to train those models, and it's too expensive. We open source a lot of our performance improvements so that folks can actually leverage those by default in the open source community. We often do that through LLM Foundry. Sometimes we even upstream changes into PyTorch for this exact purpose. We did also use a lot of different other products within Databricks. Actually, there was a smaller company called Lilac AI, which has a really, really great tool around data exploration and curation. And we knew them from other things and actually used their product really, really heavily, and we loved it so much, we ended up acquiring the company. Their product is really, really useful for NLP, like just text exploration, constructing your data set, really understanding your data. That's what we're about kind of at Databricks. But that data is like 12 trillion tokens worth of data is a lot. So we have this thing called Apache Spark, which we use to train data and clean that data, and it was super, super useful for us. It cut down the amount of time to do pre-processing from the order of months to the order of weeks, which was really impactful to our timeline. All of this data, it's critical that it have lineage and that it be stored in a way that's governable for enterprises. So we have a governance solution called Unity Catalog in which all that data lives. And then, we have a training product and platform that we actually use to train the model. And MLflow is what we use to do experiment tracking. And so that one's really close to my heart because I started out my career working on MLflow in the open source. And so I think it's really exciting that we were able to use all these open source tools. We serve the model in our Foundation Model API service. That's what I work on. And we have a playground for folks to evaluate the model and red team it. There's a lot of open source projects that we used here, and we wanted to call them out. Megablocks is one, started by my friend Trevor Gale. Actually, we were in the same lab, sat across from each other at Stanford. And we actually loved Megablocks so much. I mean, other folks use it, like Mistral. We recently brought it under the Databricks umbrella of open source projects. PyTorch FSDP is the basis for our distributed training library. And PyTorch is an incredible open source project that we've really loved. We work really closely with the PyTorch team.
And don't forget the Linux Foundation project too, right? So.
Yes. So is MLflow.
So is MLflow. Yes, true.
And we used VLLM and TensorRT-LLM are both open source serving frameworks that we contributed to the day we released the model. We leverage versions of these within our own stack in the product that we sell. And we're one of the leading contributors to TRT-LLM and also to VLLM. Also wanted to thank Eleuther AI, which is an open project, for their LLM evaluation work. We collaborate with them a lot on that kind of stuff. And folks at the Allen Institute for Artificial Intelligence, who helped us a lot on the data side in particular.
And they're based here in Seattle too, just FYI.
Yeah. So yeah, how does the model do? Well, it's amongst the best models when it was released that are commercially viable open source models. When we compared it to Mixtral and Llama 270B, it was substantially better. On leaderboards, we're doing a lot better than Mixtral. One of the scores that we're the most proud of is actually human eval. And like Denny said, it's very confusing. That's actually a programming benchmark. But on that programming benchmark, we're actually crushing code-specific models. So like Code Llama, for example, is trained purely with the Llama architecture from code tokens only. So it's just a code model. And we're beating that model with many fewer active parameters. Remember, I said 36 billion of those parameters are active. So it's almost twice as fast as Code Llama 70B while being higher quality on code. And this is actually, you can see it reflected in stuff like the chatbot arena, where they recently broke down the scores by task, and our model is higher than GPT 3.5 quality, and as the top open model still on coding in the chatbot arena. So we haven't yet had a chance to run human eval on Llama 3 70B, but we're really excited about where it's going to land. So I think for folks who use code in the open source, it's going to be a really exciting development. One of our goals was to make it so that we had a model that was open, that was better than the closed models we see being used in enterprise. So we were really excited about this result. In fact, even though GPT-4 is the highest quality model, most folks in enterprise are using GPT 3.5 due to its really, really good latencies and low cost. DBRX can be served with lower cost than GPT 3.5 and has higher quality. And that's really resonated with a lot of folks that we work with. I think that actually might still be true relative to the Llama 370B model because, again, it has half the active parameters. So we have a lot of internal use cases as well. On our SQL-related internal use cases, DBRX surpassed GPT 3.5. It's actually right up next to GPT-4 on those internal SQL-related use cases. We're outperforming on MMLU, which is a great benchmark, but programming and mathematics are things that we're really excited about. Conversational abilities are something that we lag on, and we want to be open about that. Mm-hmm. And so we're still working on, this is like the first checkpoint for us, and we're going to continue improving this model and have more exciting announcements around it. Another thing that we see that's really common in enterprise is long context tasks. And there are very few good evaluation benchmarks on that. So we're really, if you look at the scores here, we're really excited about how DBRX is doing on long context. In general, long context is tricky because even if you pass a lot of tokens into the model, there's this kind of problem where it forgets what's going on in the middle of that thing. And so we actually specifically had that in mind and trained the model to be good at long context. Our enterprise customers who have tried out the model with their production use cases are actually really excited about that. We do want to be, GPT-4 Turbo is definitely the best model in this area. It's actually better than GPT-4. And then retrieval augmentation is another important task that people care about, DBRX is outperforming open models on that. And RAG is kind of the one thing that everyone is doing with these models in enterprises. So the way that we think about the benchmarks we care about is actually not necessarily gaming for MMLU. We're really more excited about our RAG evaluations, our long context evaluations, and our speed, because those are the things that the enterprise customers are really giving a lot of interest in. I wanted to really briefly cover the training stack. We did evaluate the efficiency of the model. When it was served, we conducted internal red teaming. And we evaluated the benchmark on, I guess, DBRX Instruct is it's kind of, you can think of it as a fine-tuned model, right? So we've compared it with other equivalent fine-tuned models on a variety of these benchmarks. But if you look at our training efficiency, that's something that comes out of our open source training stack. So the amount of what we call flops, floating point operations, that were required to train this model is way fewer than a dense model, because the MOE architecture is like the stack that we have is able to train MOE models at a much higher overall utilization of the GPU. What that means is that you're getting better value in terms of, like, let's say for any given second you're improving the quality of the model by some amount, you're getting increasingly high value on that with our stack. So this is like kind of something that we've open sourced. We've given a lot back to the open source community here in LLM Foundry, and folks have picked it up and have picked Composer up and actually been able to get these improvements in the training stack automatically. Inference is something that's close to my heart. This is what my team works on. So we call it FM APIs, Foundation Model APIs. DBRX achieves 150 tokens per second, which is insanely fast. That's like humans can read at 100, maybe at 80. So this is faster than you can read by a substantial amount. And what that means is that even if you hit it with a lot of concurrent requests, it'll slow down a little bit, but it's still really, really fast. And so in general, there's a trade-off for enterprises. You either get quality that's slower, or you get less quality but faster. And so here what we're delivering is something that's 2x faster than Llama 370B, which is a number from this morning, because it has half the active parameters. So Llama 370B might be higher quality, but if you need a little bit more speed for the same amount of quality, we're able to provide that on this MOE architecture. So we have some benchmarks here, which we're super excited about. And these are actually much harder to become outdated, because the bigger models like 70B, like the quality might improve, but the actual inference efficiency doesn't change. So we've got like a benchmark here, or like a GIF. I think maybe Denny showed this one.
Yeah, I think we showed this one earlier.
But
yeah, my bad.
Yeah, no, it's fine. It's always fun for me to see like how fast it responds. So we're really it's really awesome that the time to the first token was maybe half, and the speed was almost 140 tokens per second there. So we actually do love our own model on the serving stack, but we are really kind of more about delivering open source models to enterprises at Databricks for the model serving stack. So that doesn't just include DABRX. It also includes Mistral, Meta's Llama 2 and 3, and a couple Hugging Face's StarCoder. We allow you to serve LangChain models, Llama index chains, your own Python code if you want. And if you do want to go the route of using a closed source model, you can always use OpenAI governed through our model serving platform. So why do we allow, what I'm really excited about here, and a journey I go on with a lot of customers, is most people are going to start with the highest quality closed source model. But by giving them an open source alternative with the same API in the same platform, we can actually achieve a way to actually switch that towards open source. So yeah, we're super excited about how the model is doing. We think it's the best choice for enterprise. Wanted to hand it back to Denny to talk about how you can try using the model.
Perfect. Thank you. And so just to add to what Ankit was covering, yeah, we've got 10 minutes left, so perfect. This will be only a minute. It's an emphasis on how efficient we can process the data. Again, we went ahead and actually placed a lot of that learnings directly back into LM Foundry. But also there's a call out, consistent call out to this presentation about how high quality is your data. If the better the quality of data you have, the better your model is going to turn out to be, right? And then this is the reason why we're talking about this idea where it's not about necessarily building the one big model. That's what most companies are not asking for. What they're doing is they're trying to get multiple models to be designed for, multiple smaller models designed for their specific use cases. That's why you hear us talk about RAG, right? Retrieval Augmented Generation. And so that's the call out, that a lot of that stuff, giving you, your customers, your companies, that flexibility is ultimately what it comes down to. And again, trying to find that balance between extremely knowledgeable, but also extremely performant. Now, how do you try it? Like everything else, go to Hugging Face. There's a Databricks DBRX base and DBRX Instruct right there. There's an AI, if you want to use Databricks, all the more power to you. There's the playground, the AI playground, or the foundation model API that you can go use right away. U.com and Perplexity AI, within, I think, a day of us releasing the model, already put our models up there, which is really sweet. Those are definitely things you can use. I've got some screenshots about, like, for example, running DBR Instruct. And Hugging Face, in this case, you can definitely use it for free. And I actually asked the question of what are the techniques to make a proper espresso? Its answers are quite good, actually. So if you may or may not know me, I'm a bit of a coffee snob. So actually, these answers are good. So if you want, again, the AI Playground, you saw the animated GIFs. That's what this was. So I'm going to skip through that one. This is me actually interestingly answering to summarize the MegaBlocks paper. So when I originally didn't know what the MegaBlocks paper was about, I said, OK, you know what? I'll just ask DBRX for it. And then sure enough, boom, it explained it to me really nicely. U.com, put a little animated GIF there. Perplexity, put a little screenshot there. So relatively straightforward. I also have a bunch of links here. So I'll work with the LF folks to make sure you have a version of these slides. Basically because we have little gists, on how do you locally query DBRX using the foundational API running from your own laptop. How do you go ahead and use DBRX with PySpark AI? So if you want to use the PySpark AI project to generate PySpark code, then guess what? That little trick there allows you to go do that. Also, a Llama Index is a very popular tool for using for RAG. Guess what? We also have that little ability for using DBRX with Llama Index. All of it's free, downloadable. Now, how do I go ahead and run this on my my laptop? I'm just going to pause, and hopefully this demo works. We'll find out. Okay. And this is what happens when you try to run stuff live. All right, so I had already warmed it up, and so you guys should be able to see? Yes? Okay, cool. So I'm going to ask, let's see, sure. Okay, it's asking the question, Moscow. Let me make it a little bit bigger so it's easier for you to see it. All right, now this is running on my own personal laptop, okay? So then I asked the question, okay, what is the population of Moscow? All right, and it should run. We'll find out if it actually does. There you go. There we go, perfect, all right. All right, 12 million. What year is this from? So what you'll notice is there's, on the right side, there's a spike of the blue. Sorry, let me move this over so you see it. There's a spike of the blue there, okay? And that spike of the blue, sorry, are you seeing it? Okay, perfect, sorry, couldn't tell from the angle. The spike of the blue is basically the GPU that's being pushed, okay? And you'll notice that the CPUs are, outside the efficiency ones, which it doesn't really matter, the performance ones are not being talked at all. In other words, I'm running DBRX right on my laptop right now, okay? So, and then of course, Jonathan Frankel, who's the chief scientist for neural networks at Databricks, is gonna hate this answer, okay? So just calling that out. Which bagels are better? Montreal or New York? Let's see what happens, because this is random. I don't know what the answer is going to be. All right, perfect. All right. Multiple times I've ran this, and it has given me, my personal opinion, the correct answer, which is Montreal bagels are better. Yes, that's right. Montreal bagels are better. That's right. OK, so I'm calling that. Jonathan hates me for this, and he constantly beats me up for it. But you'll notice it coming directly from the laptop. Now, saying this is the Llama CPP project. It is a heavily quantized version of the DBRX model. Mind you, the model just literally had been pushed in, I want to say, over the weekend. Okay, so it's just done by some folks in the community. They basically took the project and basically updated Llama CPP to handle the MOE architecture, number one, and then afterwards they went ahead and heavily quantized it so it could actually fit on a 64 gigabyte RAM laptop. Okay, now there's a 4-bit quantized version of it, which is better quality, created by the folks over at Apple using Core ML. That one is probably more nuanced answer than the answer that you see here. But that one requires you to have 96 gigabytes. So that's why I'm running this one, because at least I only need 64. Okay, so this is just a little bit of fun we have here right now. That's all that is. But ultimately, the point is that there are multiple ways for you to try out DoubleX, okay, including playing with the laptop. So the TLDR from everything, as we wrap up for the last minute or so, basically it's a DBR is a state-of-the-art, high-quality, open-source model. It sets a very leading. I want to change that from new standard to leading standard now, because again, with Llama 3 and Mixtral coming out, we no longer can claim the king of the mountain anymore. Compared to proprietary models, DBRX Instruct surpasses GPT 3.5 and is competitive with Gemini 1.0 Pro and Mixtral Medium. The fine-grained sparse MOE architecture with 132 billion total parameters. I think we've probably hammered those numbers over and over again too much. Only 36 billion of them are used. 416 experts are leveraged when we do such a thing. It's built as a combination of Mosaic research, Databricks, and the AI community. This would not happen unless we're working closely with both the research communities and the open source communities. Okay, this works because we all work together. Okay, and that's a fundamental belief that we have, not just from Databricks, but all of us who work here. Okay, on this idea that we want to work with open models. Okay. All this other stuff about GPT-4 tokenizer, MOE architecture, we already covered it. So, but that's the key thing here. I want to sort of leave that context that's why openness is so important, because it allows us to improve not just each company's usage of these models, but actually improves the actual models themselves, the new techniques that we're all going to try to use. We're all learning from each other. That's why I have, he's slept very little, I've slept very little, not because we're overworked, well actually we are, but that's not the main reason. We're super excited about the stuff. The fact that we're breaking new ground almost every day basically wakes us up anyways. That's why this stuff is so exciting, basically. So I think, yeah. This is how I'm going to end it. If you want to learn more, there's some even better experts than us two lowly peons. Okay, there's Naveen Rao, a VP of Generative AI from Databricks, formerly CEO and co-founder of Mosaic, and also Jonathan Frankel, Chief Scientist, Neural Network, former co-founder of Mosaic ML as well, and of course lover of New York bagels and where I piss him off. But you can register for the webinar on April 25th at 8 a.m. where we dive into all these things as well. Okay, and I think that's it. Yes, that's it. So hopefully we've covered most of what you want, and I think that's it, right?
Yeah, we're good.
All right, perfect. Yeah.
We'd love to hear any questions you have.
Yeah.
Can you share a little bit about the license that you chose to use?
Yeah, I have some. I can talk a little bit about that.
Sure, go for it. Okay.
So we basically went with a license roughly resembling the Llama 2 license, and that's kind of what we went with there.
Is that open source? If it's for Grandmaster Russian, it's not open source, I think.
Okay, so there are different grades of, okay, whenever anybody asks what is an open model, okay, there's actually going to be very, very different debates on this one, okay? So one of the things that we're actually, and in fact, I was just talking to Nancy early this morning about it, we're actually working with the Linux Foundation on their open model, basically a matrix. Okay, in terms of what's the level of each openness. The reason we went with the Llama 2s is a combination of it's out there, so it makes it easier, number one. But just as important as that is also the fact that there's often derivatives that are, I'll use the word spicy, okay, that are invalid or things that we don't want to actually happen to the models. So that's the reason why we follow the same Llama 2 model. Now, saying that, we are also working with the LF specifically to specify which grade of openness, quote unquote, that we actually follow. So that way it's a lot more transparent. The problem is that depending on who you ask at what time, they have different answers to that question. And that's the reason why I can't give you a straightforward answer yet, because we all go through this problem right now. Okay? So.
Yeah, I mean, from my point of view, I don't think there's anything in our license that prevents the community from using the model.
Yes.
It also doesn't prevent enterprises from using the model. So the folks who are mostly prevented from using the model are like Meta or
CSPs themselves.
CSPs.
Yeah. So. Cool.
Yeah.
If I want to fine-tune DBRX with my own enterprise data and my own private cloud, if I want to fine-tune DBRX with my own enterprise data on my own private cloud, what do I need to, how many GPUs do I need? What do I need to spec out for the infrastructure?
Yeah, I would look at somewhere between 32 to 64 GPUs to fine-tune it.
What type?
H100, A100, one of those two.
And does that vary by the fine-tuning data set?
Somewhat, but not too much.
Yeah. Yeah, as you can tell, it's not a cheap thing to do.
Yeah. If you want a software stack, though, you can pick up the LM Foundry and it'll work out of the box.
Yeah. And part of the reason for the existence of LM Foundry, by the way, is also it's a lot more efficient. So you can actually make use of the GPUs you have with a lot. You don't actually have to. You don't have to basically have it running for 3 months straight, right? You're a lot more efficient. That's why we're able to build this DBRX in 3 months, right? Sure, we had basically 3,000 plus GPUs, so a little bit more, right? But the reality also is that if you were trying to do the same trick last year, which like even GPT 3.5 or 4.0, we're talking a heck of a lot more GPUs than we're talking about right now. So there's a massive amount of efficiency that we're putting in, and that we also place into the open source community by basically upgrading and optimizing LM Foundry. So so we're not there yet where I can just run it on my fine-tune on my laptop yet. We're trying to get there, but we're not there yet. So, yeah.
Cool. In the middle.
So this is like a 1.0 release. I'm assuming you're gonna iterate and do further.
Sorry, could you repeat that for the stream?
Sorry, this is kind of like the 1.0 release, I'm guessing. So you're planning to like iterate and improve and release further versions in the future, right?
Yeah, we've got an aggressive roadmap around the model and around generally our capabilities in the space. So we're doing more stuff on this front.
Awesome.
I think there's a question in the back.
Will you be providing this in any of the cloud providers, like at Azure or AWS or anything like that?
So it is already provided as part of Databricks in those clouds. So Azure Databricks is part of Azure. And so if you're on Azure, you can just start up an Azure Databricks instance. We have the product that I work on called Foundation Model APIs. It's available there on a per token pricing basis and also for production use cases with your own endpoint.
And does Databricks provide services to do fine-tuning?
We do, yeah. So for those folks who don't have 32 to 64 H100 GPUs, we are happy to provide those, and we charge pretty reasonable prices for fine-tuning.
Cool. All right, well then thank you very much, everybody. Appreciate it.
Recording in progress.
In 2024, Linux Foundation Research is launching a collection of studies on important open source topics, and we'd like you to get involved. Primary research is a benefit to the whole open source community, helping guide data-driven decision-making, improving brand visibility, engaging in thought leadership, and providing early access to insights. Our research produces valuable new data on open source.
Hello. All right, good. Welcome. Thank you for joining Linux Foundation Research Turns 4. My name is Hillary Carter. I came to Linux Foundation 3 years ago to launch the research program. And I'm happy to be joined by my colleague Anna Hermanson of LF Research. Anna, I'll hand you the mic.
Thanks, everyone. Thanks for joining our session. I've been working with Hillary on the research portfolio for 1.5 years now, and I'm excited to share what we're getting up to this year. I think it's our biggest year yet, at least shaping up to be, so lots to update you all on.
Thanks, Anna. All right, so what we essentially what our mission is at LF Research is to measure trends in open source and describe through empirical data how research is impacting industries and technology domains, as well as other reference frameworks. So yeah, this is our mission, ideally to provide empirical evidence on the impact of open source collaboration and how open source is being used to solve some of the most pressing challenges in the world, everything from improving software security and using the principles of mass open collaboration to improve software, to address issues such as climate impact, to address social justice issues, and so on. So it's a very large scope, and given the breadth and impact of open source worldwide, it's kind of a challenging task to be able to tell that story through individual research projects. But this short video that we'll play will give you the high-level view as to what we're all about. So it's just a click, right, Anna? Here we go.
In 2024, Linux Foundation Research is launching a collection of studies on important open source topics, and we'd like you to get involved. Primary research is a benefit to the whole open source community, helping guide data-driven decision-making, improving brand visibility, engaging in thought leadership, and providing early access to insights. Our research produces valuable new data on open source trends within industries and technology domains, and across other important reference frameworks. Geography-specific research identifies the unique characteristics of open source ecosystems in different regions of the world, informing resource allocation. Taking a data-driven approach to worldwide open source communities helps to reduce fragmentation and create pathways to greater collaboration. Our research also gives industry leaders an opportunity to share subject matter expertise for the benefit of others. Qualitative research is a proven way to engage stakeholders and bring fresh perspectives on the value of open source to new audiences. Analyzing software datasets from Git repositories or SCA vendors identifies trends in corporate contribution policy and informs approaches to making software more secure. So join us in creating data-driven insights that benefit all open source communities. To become a sponsor or sign up to participate in surveys, please email research@linuxfoundation.org.
All right, so there you go. You will have noticed in the video the use of a lot of infographics. These are core deliverables of what we create, and they're nice because they're multi-purpose. They serve as visuals that capture high-level data points and that can be shared in social media posts and presentations quite nicely. So the core of what we're producing is often a research report, infographics, and open data sets. And everything that we do is community driven. We create research for the community, with the community. So we're definitely not able to do so in isolation. It is very much a collaborative exercise. It's what I refer to as a team sport of a different kind. Since our inception, we were launched in April of 2021. We have produced more than 50 unique research projects. This slide captures just a few of the covers of some of our more recent research. And we have research that as you might have noticed in the video, focuses on 4 key areas. Industry, covering some of the industries where the Linux Foundation has a strong presence, the networking space, financial services, motion pictures, if you're familiar with the Academy Software Foundation, as well as automotive, if you're familiar with the automotive grade Linux group of projects. And understanding industry-specific impact is very important, and it helps facilitate decision-making and strategy within industry. What makes one industry unique from another? And the needs of industries are especially regulated, highly regulated industries like financial services have very different technological needs and approaches than those that are less highly regulated. So there's some interesting industry challenges that we're helping to both identify where open source is critical in addressing some of those industry challenges. One of our commitments is to creating open data. At a very high level, we produce open content. All of our research reports are available under Creative Commons license. So you can download our reports for free, publish them on your own websites, share them, sell them if you want to, as well as giving access to the data, the raw data sets, I should say, clean data sets that are free of personally identifiable information. And this allows our community to do their own research with the data that we have gathered and create opportunities for testing the assumptions that we have made in our, or the analysis that we have produced in our reports, and potentially create opportunities for a different perspective if they use a cut of our data for a different approach. So our commitment to transparency and openness is really fundamental. What we have found as a function is that we are creating primary research that really doesn't exist. And as a result, industry analysts from organizations like Gartner, you'll see Tony Iams is a Gartner VP, who's accessing our data sets on data.world for the purpose of producing their industry reports. So our ability to be a resource for leading analytics firms and consultancies, the Gartners, the Forresters, the McKinseys, is really quite validating and rewarding. And they're really coming to us to understand what's taking place quite broadly in technology and within industries. So if you're curious as to what our data sets look like, visit data.world and look up the Linux Foundation's collection of research data. It's critically important as we create research to engage the open source community broadly. It's not something we can do in a silo. Bringing together the points of view, the expertise across our community is essentially our value proposition. It's vital that we bring in the unique perspectives of the open source community, because that is what makes Linux Foundation research unique in the marketplace. And we would just not be where we are today without a very robust level of engagement. So I'm going to describe some of the ways in which our community has engaged in the research process, and for you to think about how research creates opportunities to engage communities and to bring in subject matter expertise. And we hope that we can be considered a mechanism for expertise to be conveyed more broadly to a broadly audience from anybody. So here's an example from spotlighting Stephen Augustus from Cisco. Stephen wrote the foreword, essentially the introduction to one of our research studies on maintainer perspectives on open source software security. And it was hugely validating to see somebody as high profile as Stephen to endorse the work through his contribution, and which had the added benefit of Stephen then becoming an advocate by posting the research on social channels and really helping with the knowledge transfer. This is a kind of amplification that we just don't have. We have a great following community on Linux Foundation social channels, but there's nothing like community advocacy for your work. And so by bringing in people and thought leaders from our community and giving them opportunities for their own thought leadership and to have their take on a given piece of research is something that we like to do, and see that it's catching fire. It's not always easy to get people to contribute to research, but when it happens, it's really quite magical. A lot of organizations are constrained by their comms departments or their legal departments in terms of what they can say, what needs to get approved. But when it comes together and people can contribute freely and with full attribution, that's when magic really starts to happen. So we were really grateful for Stephen and so many others in the open source community who have gone on record to add to our report and be attributed in that process. So I want to highlight a few other noteworthy contributors to Linux Foundation research here. We are fundamentally supported by the Linux Foundation Platinum member community. Through their membership, we're able to stand up new community projects like LF Research. And we have created a Platinum member benefit so that anybody on our board can participate in research advisory activities. So we host quarterly advisory board meetings, which are comprised of any Platinum member of the LF that wants to get involved, along with others. And we consequently have a very engaged community at a very high level. So Nithya Ruff, who's the chair of our board, has been a terrific supporter of research. She didn't initially join the LF Research Advisory Board, but over time she said, I really want to get involved and have an influence on the research agenda, and be able to help make connections to the interview process or help distribute surveys, things like that. Phil Robb from Ericsson also serves on the research board, and he has been equally supportive, conducting peer reviews of surveys. And his colleague, Jimmy Alberg from Ericsson, has written a foreword for research as well. From the FutureWay team, Annie Lai and her colleagues Chris Shi and Yue Chen, Wenjing Chu. FutureWay is an extremely supportive organization, highly engaged in research, and they have seen value in getting involved in research, providing sponsorship for research, because these are door-opening activities that improve collaboration, that help with the project formation exercise, that help build the kind of building blocks for other more strategic initiatives. One example is Open Source Congress, a a live event that convened the open source leaders across foundations in Geneva last year. Because of FutureWay's engagement, they said, listen, we've got to bring all open source foundations together to have important conversations about how we can improve cross-foundational collaboration on issues that we all face, on things like how do we improve our response to regulation that impacts open source, regulation like the Cyber Resilience Act. We are better and stronger together. And research is, often the first step in a broader conversation to bring about collaboration, because it starts with data. Once you have the data, then you can build on the data and saying, look, the data says we should be talking to one another. Let's start talking to one another. And that's how it's happened. And that's the leadership role that FutureWay has played with LF Research. Pei Jin, who from Huawei has also sponsored research, serves on our advisory board actively. I think he joined in the middle of the night last night to attend our afternoon meeting, which was much appreciated, or first thing in the morning. I can't recall which end of the day he was. Jessica Murillo from IBM has written forwards. She's appeared in research webinars, hugely supportive. She also sits on our advisory board. Jochen Friedrich, also from IBM, has written forwards and has supported our standards research in a significant way. Melissa Evers and Arun Gupta from Intel have commissioned research, have conducted peer reviews of studies. David Marr from Qualcomm has written a forward for an LF AI and data. No, it was an enterprise, a guide to enterprise open source. Leslie Hawthorne and Cara Delia from Red Hat, two active contributors, both in terms of co-authorship and contributing forwards and peer reviews. Andrew Aiken from now Hedera has been a co-author of research in the financial services sector. Elspeth Minty from RBC Royal Bank is a unique contributor to research, and RBC Royal Bank being a large financial services, large global bank, essentially. It's a Canadian bank, but it is in the top 20, might even be in the top 10 worldwide. Many times, employees from financial services organizations are prohibited from contributing code. But what they can contribute is their time and their talents to other projects. They can participate in working groups, they can participate in research, they can give interviews, and they're very, very active in the community. And so that's one thing that we're seeing, a great example of a person from a highly regulated industry making active open source contributions. And it's really terrific to see. Liz Rice from Isovalent, Brian Fox from Sonotype, I need my glasses again. Paige Bartley from S&P Global, Stella Biederman from Luther AI, and Miles Borens from GitHub. So you can see a real cross-section, people from industry getting involved, people from, telecom and IT vendors, and it's a very rich experience. There's a lot of opportunity to engage with some exceptional people, and they care deeply about the work that we're doing. So this is our support team, and we're very, very lucky to have them on board. One of the ways that we recognize contribution is through Credly badges. There can be any number of contributions. In the previous slide, I recognized the ways in which some of our senior leaders are contributing. Oftentimes it's sponsorship or writing a forward. But analyzing data sets, maybe even ghostwriting a section of a report, being an in-kind contributor of one form or another, a data set contributor, a localization partner. We issue badges based on the level of, or the type of contribution to recognize that contributing in research is not unlike contributing to the success of an open source event. As a speaker at Open Source Summit North America, I'm going to get a Credly badge that says I was a speaker, and that's a great thing. And so research recognizes contributions in that same way. And again, it's terrific when folks like Phil Holleran from GitHub share their contributor badge on LinkedIn or other channels to say, hey, I'm really happy that I was able to play a role. Phil and GitHub have contributed data sets to the FinTech and Open Source Foundation 3 years in a row. And that data has been so valuable because it has identified people from financial services organizations, again, a highly regulated industry, and who is actively contributing to projects on GitHub using their corporate email address. And so we're able to measure, is this trend changing? And year over year, we've seen a terrific upward trend that now organizations, banks, asset managers, and other types of financial services enterprises are relaxing some of their policies around the types of open source contributions that their employees can make. And this is huge data. Phil keeps contributing it to the Finos research project, and we're very happy. And then, of course, we're really happy that he's happy and shares it on LinkedIn, too. And so diving into the kinds of questions that we're able to answer through LF Research, one of the most important questions that we need to answer is what's the most widely used open source software? Why is this an important question? Well, when we know what's the most widely used software, we're able to prioritize the projects that we ensure have what they need in terms of security. We want to make sure we know who maintains it. Is that maintainer in need? We saw this with XC and the social engineering threat. Who maintains that software? What resources do they need? How can we help them? And do they maintain a critical, highly or widely used piece of software? And that's how we secure open source software effectively, is through this kind of primary data. Once we know this, then we can move to allocating resources accordingly. And this question has been answered in our census work, most recently with Census 2, a collaboration with Harvard's Laboratory of Innovation Science. And Harvard has analyzed data sets from SCA vendors, software composition analysis vendors. In Census 2, we had data sets from FOSSA, Sneak, and Synopsys. So 3 vendors provided data that we could analyze and identify what the most widely used software is. It's not a perfect measure by any means, but it's a starting point. We're re-engaging Harvard presently to conduct Census 3, and we're hoping to work with more SCA vendors than just 3. We have FOSSA committed. We have commitments from new SCA vendor organizations and other types of cloud service providers. And what we hope is we can get an even more precise picture of the world's most widely used software to then conduct the other activities and to direct the efforts of organizations like Alpha Omega, the OpenSSF, and so on. Interestingly, when the first census was run, I think it was 2015, it was called Census 1. It was exploring vulnerabilities in the core, and there was analysis done at the operating system level. In that research, XZ was identified as one of the applications then. And the debate is, well, you're giving malicious actors a menu to choose from. But it has not stopped research. There are more people who think that understanding this research is more important than not doing it at all. And so we carry on. So we'll hope to have Census 3 out this calendar year as we secure our data set contributions from our partner organizations. So I should say, if you are an organization, know somebody who is considering making such a research contribution, please get in touch. What do maintainers need? This is linked to the census work. And as a follow-on to Census 2, we identified some of the maintainers of the most widely used software at the application library level, and we interviewed them. to create this report on open source maintainers exploring the people, practices, and constraints facing the world's most critical open source software projects. And here's the high level what they need. They need more time to respond to pull requests. They need more time to address vulnerabilities. And they need more time to onboard new contributors and think about the legacy of their project. They need tools to give them more time. And yes, they need funding. They need resources. So it's now up to us to address and meet their needs. Another great question, how do we increase upstream contributions? This report that we did in partnership with the To-Do Group and others, the 2023 State of the OSPO and Open Source Software Initiatives, has some great data on engaging communities so that we can increase upstream contributions. The big takeaway from this report is that organizations with an open source program office are 4 times more likely to contribute upstream. So it really validates the OSPO as a structure. The work that we've done, particularly last year through our Global Spotlight report, validates the open source value proposition significantly. And that was a really exciting finding. That there is widespread consensus in our community about the value of open source, faster time to market, a vital tool for innovation at so many different levels. The benefits far outweigh the costs, that it's more secure than closed source, and that it leads to overall productivity and software quality. So these were exceptionally encouraging findings. But not all research produces encouraging findings. In fact, sometimes the data is uncomfortable. At the same time, that uncomfortable data helps us drive strategy, and it's very insightful in terms of how we allocate resources. The same study produced 4 findings that are sobering, and realize that we have a lot of work to do in terms of our communication, disseminating the value proposition, and making sure that policy stakeholders and other decision makers have a better understanding of open source over time. So with that, I'm going to invite Anna up to dig into the 2024 research agenda.
Thanks, Hillary. So as I mentioned when I first got up here, we have a really big year this year, and we're really excited to be running some research with a number of organizations across our community. And so I just wanted to give a bit of a picture into some of the work we're doing this year. For example, how has generative AI impacted the technical talent market? We just answered this question in our research report, which we have in the front here in physical copy, which is exciting. But we ran a state of tech talent report with LF training and certification to ask questions like this. How has Gen AI impacted? How has economic headwinds impacted the technical talent market? We're also looking at what is the economic impact of open standards? Why do technology organizations want to deploy open standards? What's the economic benefit? We also are asking what is the open source value proposition when it comes to health data? How can we use open source technologies to better support the system that is currently quite monopolized by monolithic entities? How can open source facilitate energy grid interoperability? How can we create a framework of securing software job descriptions? What is being used in the cloud native space when it comes to securing those applications? So we have a lot of different research going on. Again, this is just a sampling, and a few of these I'll take you through in a minute. We'd also like to highlight the amazing group of collaborators. Hillary went through a few of the individuals we work with. We work with a lot of entities within the LF and outside of the LF to support our research as sponsors, in-kind contributors, research partners. And so, you can see within our organization, we work with LF training and certification, LF AI and data. We also work with, we're working right now with Natural Resources Canada, data. We work within our member communities such as AWS and Intel. So we're very lucky to have a lot of organizations that want to run this kind of research and answer these research questions with us. So as just mentioned, we recently published, I think 2 days ago, we announced the publication of the State of Tech Talent Report. This was, I think the LF Training and Certification has been working with us for a number of years to produce a jobs report, and this is the second year where we surveyed actual technical hiring managers. And so this year, we wanted to understand the impacts of these economic challenges and technical trends in that market. And key findings indicate that the Gen AI is not necessarily taking our jobs, but it is impacting the way that we understand and perform our jobs. And we also found that despite these large headwinds despite these large headlines we were seeing in 2023 about technical layoffs, it's a bit more of a nuanced picture than what we were seeing in the headlines. So a lot more findings. Again, please come take a copy up here or scan the QR code. You can download it digitally. We also are running a number of surveys. We have 3 in the field right now with a few more launching. So this first one is a part of our World of Open Source series. This is our Global Spotlight survey. The key to this survey is to provide a lens into what open source trends look like in different geographies. And so this focuses on the use and consumption of open source, contribution trends, how organizations and governments value open source. And so this will turn into a number of different reports that look at geographic segmentation. So there will be a Europe version, there will most likely be a Japan version, and then a kind of larger picture worldwide view. So this just opened. I think if you caught Hillary's keynote on Tuesday, this was launched this week. Our State of Open Standards 2024 survey was also launched this week. We ran this survey last year with the standards group, with Jory and Mike, and we found that we were really trying to articulate how do you define an open standard, and is there a preference to open versus closed standards? And we found quite categorically that open standards were preferred by our survey takers. And so this year we're trying to understand why they're preferred, what is the value of an open standard and the economic benefit of this open standard. And so in this sense, we're really trying to get the business and legal use case of an open standard. So this one is just opened as well. And then we have one that's closing, I think, in 5 or so days. But this is the survey we're running with OpenSSF. And their goal of this survey was to understand where there might be gaps in education, and specifically when it comes to developers who need to be educated on secure software practices. And so this one, we've already gotten quite a bit of sample, but if you have a say in this topic, please feel free to take the survey before it closes. And we have 2 more surveys coming this week, or in the next few weeks. The first one is the Open Source Developer Relations Survey. We've partnered with Intel, who want to have a better picture of what developers need in their career journeys, whether that's looking at the short-term career development or a longer-term career path. And so we're looking at how developers rank things like events, training, mentorship, and research. The second one listed there is the Cybersecurity Job Role Survey. This is also some work we're doing with LF Training and Certification, and as well as ISC2. And the goal of this research is to validate a list of job titles and their responsibilities as they relate to secure software. And so we want the community's feedback on whether or not we've adequately captured all the different jobs that go into securing software and how we can make that comprehensive and mutually exhaustive. I just wanted to plug our research team. We have Steve Hendrick, who is the king of data analysis at the LF. He's been running all of this research, and he's also been working with 3 other employees. We have Bianca Trinkenreich, our newest data analyst, Adrian Lawson and Marco Gerosa. And so we are indebted to them for running 5 surveys in a month. So thank you. I don't know if they're watching, probably. And then I also just wanted, let me see I have a few more minutes. We do have a few qualitative studies we're running as well. I just wanted to plug these. We're running one with FutureWay and MIT Media Lab on what does decentralized computing look like if we use an open source kind of approach or process. And so the focus of this research is to understand this concept of decentralized and federated computing as it relates to different areas such as social media, so thinking Mastodon, software development ecosystems, payment ecosystems, thinking crypto, blockchain, Web3, and then also how generative AI will impact all of these areas. We're also running, this is a research project that I'm leading, which is near and dear to my heart, but this is a qualitative research study on how open source can be used in the healthcare space, particularly when it comes to managing health data. And so this is also, again, qualitative, where I'm interviewing healthcare professionals and technologists on how they perceive the use of open source and as compared to other proprietary systems and what those benefits are. And so focusing on the databases that could be used and the open source tooling that could be used in health data management, but also what role does generative AI play in this space, and how can we use that open source ethos of collaboration to build up a common data model, which is crucial for standards development in this space. And finally, a last feature of our qualitative research is the research we're running with NRCan, the Canadian Energy Resources Department. And so this we're working as well with LF Energy, and the Canadian government wanted to understand how to get out of that vendor lock-in issue that has hurt them in the past when it comes to their electric grid and the vendors they're using to power that. And so they're asking questions around who actually enforces that interoperability, what is the impact of IEEE standards, and how can we use open source to better harmonize these grid protocols. So as mentioned, we have a lot of research going on. We have a lot of surveys that we need. Our research is really dependent on our community, not just from a sponsor or partnering perspective, but also from individuals like yourselves to take our surveys, to be interviewed for our research. We really lean on our community to build out this repository of open source data. And so if you're interested in getting in touch, you can come talk to Hillary and I. You can also go on our website and learn more about the value proposition of joining LF Research and getting involved in our surveys. And that's it. Thank you all so much for joining. And I think we have, do we have any time for questions?
A couple minutes.
Okay, great. If there's any.
Thanks for sharing this. I'm a fan. I can't say all, but most of your reports. Yay. I have learned so much over the last 3 years, 4 years. I wonder if you can share a little bit more of, well, now I know that you have a team, 4 or 5 people. I'm sure they're super busy slicing and dicing all the data. But if you can share a little bit more of, any guidance or policies in terms of how do you perform your research? I mean, I know it's not commercial, right? I read the reports and I know you don't talk about any commercial software, even with the sponsorship. Any other, I guess, policies that you have when you are conducting the research, minimum number of respondents, or that's what I'm kind of...
Sure, I'll start, and then if you want to add anything. So Steve and his team work on we have a statistically relevant sample that we aim for in each of our research. And so this is typically around the 300 mark for sample numbers, depending on what the client would, or what the community member would like from the data. But we do always reach a statistically significant number. And then also within that research, sometimes we want to segment our data. And so Steve and his team are very careful to say, is this segmentation statistically relevant given how many respondents we have in our sample? I think in terms of qualitative research, we build an interview guide so that the person who is conducting the interviews follows a similar process of questioning, and so we don't kind of wander off too far down a path and become biased in that sense. And so, speaking more from the work that I do as a qualitative researcher, that's usually the approach we take. I think we operate in a very, as we work with the Linux, as a Linux Foundation entity, we operate very much in the open. And so we also rely on peer review of all of our research, and anything that we publish in a qualitative perspective as a quotation, we get our interviewees to sign off on. All of our research is published under Creative Commons. Do you have any other kind of thoughts? Yeah, so we build interview guides that we get our community to kind of sign off on. So, Steve has, is it 30 years of experience running quantitative research? So Steve has a really strong backbone of experience in this, and he, I come from an academic background, and coming here, the same kind of rigor and lack of bias also exists in this process. I think the nice thing about this kind of research compared to academia is that we're not mired down in, the red tape of going through a lot of, challenges or hoops to jump through, and so we can work quite quickly, but always with the mindset that we are, as we're open source, everything is transparent, and we meet these milestones or these requirements that we set up for ourselves.
Thank you. Hi, Stefan from SUSE. Signed up for my membership, so good job there. And research this morning for SSF. Question though, yesterday I in this very room, I think, listened to a very fascinating thing from the DOE. So similar to Canadian Energy, they're doing a research project for next gen of batteries, energy storage. And I'm curious, is that something you're already engaged with? I saw the report kind of in that flavor, but curiosity question, keener question.
I don't think I haven't heard of that.
Okay, it was yesterday around 2.
Did you catch that, Hillary?
Not specifically with the DOE, but we work very closely with LF Energy, and we do have a project to work with LF Energy on this year. We're not sure the parameters of that project yet.
Yeah, so it's more research and data collection. So many years and aligned with a directive for energy 2035, right? So it's bigger, long term.
Mm-hmm.
Fascinating, though.
Yeah, thank you.
The reference was lithium research that they did in 1970 and how that's paid off now today, right? So they're doing that again.
Yeah.
And they actually called for help, so that's why they were here.
Now, I should probably clarify also that we're not doing R&D hands-on in terms of technical research, more in terms of researching open source dynamics specifically. So I think that's where we're a little bit different than other organizations. That's our niche. If there's an open source angle to the DOE's interest, then it would be a terrific collaboration. For Git projects, yeah. Did you have anything further? Any further thoughts, Anna?
Yeah, that sounds interesting. That sounds interesting, and I think the NRCan project has been a little bit technical in terms of the standards and the kind of culture and dynamics around that, but less on the actual vendors and the technologies being used. But I believe our researcher's getting into that a little bit with his interviewees. But it'd be interesting to see what they're working on. And we have a lot of he's interviewing Americans as well and Europeans. So this is specifically Canadian, but.
I'll add one comment to say one of the challenges that we face is around interviewing or researching open source at the intersection of operational technology and some of the more strategic infrastructure for governments, nuclear plants, and some energy strategic the operational infrastructure, that it's very difficult to get the data. And so, I mean, it's imperative that we do these studies to understand how can we be assured that these that operational technology is secure. So we need different kinds of collaboration to think about going forward. So thank you so much, everybody. Appreciate your time and attention.
there's going to be another AV guy that's probably going to just double check with this, and then also your setup up there as well.
Let me grab that. And how do I turn it off?
Just flip this little switch up.
Woo, woo, woo. Now, can you all hear me okay? Is that coming out of the speakers?
Okay, let's go ahead and get going. This is the Yocto Project BOF. For people that haven't been to a BOF before, BOF means birds of a feather. And I believe the saying is birds of a feather flock together. And this is a word left over from the good old Unix days. If there's anyone curious why it's called a BOF and what the BOF is, basically this is a time for me to talk a little bit, summarize some stuff that has happened in the past since the last conference, basically. And then we can go into more of an interactive format, questions, answers. If you have questions, there are people here who can probably answer them. So it'll be pretty free form, and interaction with people in the audience is sort of the point of this exercise. And Paul, if you could get a mic from Joshua and sit on the other side of the room. So that was the welcome speech. Welcome to the BOF. Your MC is, normally it would probably be Joseph, the Yocto jester, but he's just got done with a week at Embedded World and wants a week off. So I have been drafted as your Master of Ceremonies today. I've been doing Yocto Project since before Yocto Project was a thing. So I sit on the Open Embedded board along with Tim here. I am the Yocto Project charter names Open Embedded as the technical partner, and we have a representative that goes to the Yocto Project advisory board meetings, and that is usually me. I'm basically a consultant, so if you ask for my title, I will write Minister of Progress, which a friend of mine made up many, many years ago. And I work professionally as OpenSDR, which is software-defined radio. And most of that work is building distributions for small software radios using the Yocto project. And I've been doing that for quite some time at this point. So we'll cover the newsy stuff, and then we'll have a little bit more. The leadership group, Andy Waffa, who is supposed to be here today, who is late, probably because I was late to one of his functions once, has been reelected as the Yocto Project Advisory Board Chair. And Stephen Geary has been reelected as the Treasurer. These are basically the two most important positions in the Yocto Project. Is you complain to Waffa if you have problems, and you ask Stephen for money. The other big news in the last several months to a year is the German government created this thing called the Sovereign Tech Fund, who approached the Yocto project about funding some of our maintainer gaps. And we were able to take the 5-year plan that had been developed a few years ago, and Megan and Andy covered this in a talk that hopefully most of you saw. But the end result was we were able to do some new work, some work that we knew existed that had been neglected. And so we've got a VS Code plugin, which is very popular. What is VS Code? An editor? Okay, I've been doing this for a long time, and I use VI. And it just so happens that I have the Yocto plugin on this laptop because I've also been looking at Meshtastic and had installed Visual Code so I could build the firmware for it. So I was very quickly to install the plugin, which is on my list of homework for when I go home from here, is to learn how to use that. They talked about patch tests, which is basically automatic testing of patches before maintainers have to review them. We're looking at publishing a binary distro so that you can prototype things from a specific distro config very quickly. Toaster has received some work, so it basically works in master now. And basically a lot of stuff has been cleaned up in it, and I've been showing it to some people here through the event to kind of show them and encourage them to try to use Toaster. And if anyone has Toaster questions, I can run you through a very little demo probably after the BOF, and some more stuff. So we're currently wrapping up the Sovereign Tech Fund work, And if you have, one of the things that I hope to get out of this BOF is ideas for new projects so that as funding becomes available, we can actually get work done. The website has been revamped. I don't know how many of you work with websites, but they're a lot harder than they look. And the website had sort of stagnated for a while for various reasons, and it's now in a state where we can actually edit it and update it again, so we can all give Megan a round of applause even though she's not here. So once again, there was a talk, The Road to Scarth Gap, that Tim gave. So this will be the next LTS, and that is going to be released real soon now. And it will receive 4 years of maintenance. So this is basically the replacement for Dunfell, which will go end of life very soon now. When does it go end of life, Tim?
The last bill is like next week.
Okay. So basically, Dunfell will go end of life, and Scarth Gap will receive LTS support. And this is where I ask, who here is using builds older than Dunfell? Who here is using Dunfell? Who here is using Kirkston? Who here is using what will become Scarth Gap? I like the one guy who just doesn't move his hand. Is anyone using things between Dunfell, Kirkston, and Scarth Gap? Okay, that's a very good number because at least people are gravitating onto the LTS releases. Other cool stuff. Okay, so upcoming events. If you were in the embedded Linux update this morning, we heard Tim talk about the attempts at splitting EOSS off to sort of its own standalone event. They tried that for various reasons that you have to ask Tim in the hall. Apparently, we've gone back to embedded events twice a year, co-located with the OSS, which is good and bad. It's, you know, some of us like to see other stuff, and it's also nice to have the the smaller format is also nice for some things. So Vienna, third week of September, there's OSS, ELC, and plumbers. And I get a couple questions about this because we had a Build Systems micro conference at plumbers last year in Richmond. I have a proposal in for that, but they are taking longer to review than expected due to excessive requests for micro conferences, including one from Tim. There will be a Yocto event planned, and it will be announced real soon now. All right. Don't mind me. Okay, and since I'm wearing an Open Embedded shirt, Open Embedded is the technical partner of the Yocto project. It is an individual membership organization. If you would like to join, the main reason to join is it gets you a vote on two seats for the Yocto project TSC. Send a short biography of you and why you care about Open Embedded and the Yocto project to board@openembedded.org, and we will batch it up and have the members vote you in as we get enough to run a vote. And there's a wiki page that also talks about membership. We did a workshop Monday after FOSDEM that we had about 35 people there, which was the capacity of the room. There are videos for that on the Open Embedded YouTube channel, and I suggest that everyone take a look at those. We most likely will organize another workshop after FOSDEM. It will sort of depend on other co-located events and runway and can we reserve space. And they don't really announce the dates for FOSDEM until late August. So we basically have to start planning for an event in February in very late August. That said, yeah, we've been running one in Brussels, and we always have the conversation is, can we run sort of small workshops with talks about Open Embedded in the Yocto project in your hometown. So if you have ideas for locations where you think we could fill a room with about 30 to 40 people and have people show up to give talks. I mean, these are run very low budget. The one in Brussels is basically 75 to 100 euros. There's an option for you to be generous. Thank you for everyone that has paid the generous price. So we, as in the Open Embedded board, can run workshops fairly easily. You know, we know how to do all the billing and everything. What we don't know is where to have them, when to have them, and who will speak. So please talk to me, talk to Tim. We are basically the local reps for that at this event. And with that, I know that at least a couple of talks, the conversations were running over or be going deeper into the weeds, and this is the part where I stop talking and you start talking. So, and I know I tried to prime some of you with questions. That's not. Yeah. Okay, so I'm going to ask a question. We've just gone through a phase of a lot of 5-year planning work. And so basically the 5-year plan is now not so much a plan as either stuff in flight or being done. What do people need from the Yocto project in the next 5 years? Marta. Wait for the microphone.
As we plan for the next 5 years, do not forget the CRA.
Do not forget what?
The CRA, the
Yes.
Cyber Resilience Act.
So the CRA is, to me, a very broad, nebulous thing. And what we need are people who understand the CRA and its implications to convert that into things that are actionable.
Understand completely. Even for me, currently CRA is completely nebulous because the standards are not there. But as it's going to be to apply in 2027 probably, so inside the 5 years, and the standards will be kind of done next year normally. So then we'll have only 2 years for any adjustments that may be necessary. So taking the buffer for that in the 5 years plan, for me, it seems that will be an important thing.
So basically, as a project, we need to be paying attention. So basically, as I'm going to turn this around, as people impacted by the CRA, it's going to be a lot better if you tell us what we need to do to make sure that we are ready to deliver Linux distributions in a post-CRA world.
Is there, even if it's not explicitly part of the CRA, is there things we could do that would be generally a good idea before then that would make it easier? Does that make sense? Yeah, because like that can be helpful. Like everyone wants their stuff to be more secure, so even if it's not specifically part of the CRA today, there might be some stuff we can do to help with that early, right? But yeah, actionable things are good.
I'm just wondering, like, what we've already got, the SBOM stuff pretty well in place. We've got representation for the SPDX3. We're getting ready to move to the new CVE formats and stuff like that, right? So there's got to be more than these concrete items, right? That's the question. So what are the other concrete items?
Yeah, I mean, that's a hard one. I don't follow the CRA as much in spite of all the stuff I put on my badge. Really, what we're saying is you could say that, the Yocto project is done. We can build embedded Linux distributions today. But the reality is we have room to work. So the security people have, I mean, Joshua Locke's talk at Plumbers about Salsa and doing builds, Linux system builds, is just fascinating. It gives you a lot of ideas. And so there's always room for improvement. And I would also like to ask everyone to please run the visual code thing and how can we make life better for individual developers. And Chuck.
Thank you. So I work in safety critical area. I think one of the impedance mismatches between the general culture of the project and the way at least aerospace safety critical works is that no, it's not okay to allow developers to sort of float to the front edge of whatever Kirkston or whatever release you're on. That's actually not okay to do. We don't allow developers to do that. We have a very careful lockstep process where we unleash the floodgates from one hash to the next. Project leadership will look at everything that rolls in, do a very careful analysis before we then open the door to the next set of hashes as the head moves. We call that floating up. But we do not let individual developers just sort of pull down their own layers and mirror. It's all kept in lockstep. It has to be that way because we have to count for what developers do. So for example, I really like setup layers, right? I like that script, but we are not going to have developers like run the script that creates that. What was it called? The build layers or the build layer. We are not, developers are not going to run that. That will never happen. Okay, we set up the developers with the setup layer script that creates, the layer setup JSON, and then that's the thing we check in to do lockstep changes. Developers just get that change when they pull. That's the way it's got to work. We don't have a tool for a project leader to say, I want to update the setup layers JSON file and update our mirrors, which by the way, we also have to keep carefully bit for bit identical to upstream because we have to reproduce that build 30, 40 years from now. So I put in an RFC in for a script to say this will update the mirrors, update that hash, and I think that was orthogonal to the thinking of the project. So I'd like to sort of like open up the dialogue on that and say that's something we need. Having to maintain that separately, that wasn't considered desirable. So, and there's some other stuff, but I'll just drop that one and we can.
So the very first phase of this, we're trying to focus entirely on new user experience, right? And so a whole bunch of us, including me, are just trying to patiently wait for that part, right, to get solidified. Trust me, we all want things like what you're talking about. And so we're just going to wait to unleash the floodgates a little bit.
So I have a bigger question. How many people in the room would be interested in such a thing? Okay, so
yeah, the idea is you run the script, it updates all your mirrors to where the upstream head is and updates your JSON. Then you commit that and you can document, I've now made a change, I've now floated up.
So we did a panel on Tuesday? Yeah. Tuesday or Monday? I'm lost.
It was Monday.
It was on Monday. And one of the, in preparing for the panel, clearly Chuck's application is just not in line with what many, many people here use the Octo project for. But one of the things we're looking for are common pieces that everyone cares about that make, there's no sense, heavily customizing the Octo project for your specific thing, except where you need to customize. There are going to be a lot of places that we share things. And the more shared stuff we have that is boring and non-business specific, I think the better we make the Octo project. So there is setup stuff in process now, and definitely pay attention to the patches and the discussion there if you care about build configuration and setup and managing how updates occur.
So the current use case that automotive uses is based off of repo. I know that's orthogonal to this, but it's the same kind of thing where they're specifically giving you a XML file that lists out exact hashes for every single component. So it's a use case. If automotive is going to be continued, it's probably a use case that has to be addressed anyways.
Yeah, I mean, there's a lot of people with a lot of solutions for layer setup stuff, and that's, if you follow the discussion, sometimes people get quite heated and have strong opinions. And that's one of the reasons there are many choices, because everyone's use case is slightly different. I mean, I use submodules because I know how to use Git, and I used to use repo and I hate it. But the first time I used repo, it was best in the class at the time. So things change, and when you're working on layer setup stuff, if anyone here listening is actually working on layer setup stuff, you're going to have to do a really good job to replace some of the existing workflows that people are using.
Yeah, and if you want to get involved in that, like if you want to figure out what the new layer setup stuff doesn't do that your personal custom solution does, then please give us that feedback.
Yeah, as we definitely, I think what I'm saying is, we can look at the solutions that people have been passionate about, but what we really need to hear from are people who, are going to use it, and, make sure that we don't create yet another tool that misses one or 2 points, and then they go back to using whatever it is they used.
So we might do that carefully instead of quickly.
Yeah.
Yeah.
I mean, layer setup is just definitely a very passionate, interesting, weedy. There are a lot of different, I do a lot of development, so I like to have all my stuff as Git repos. The people doing CI stuff like to use CAS because they have a file that explains a lot more than I can codify in a Git submodule tree.
So if you go back a few years, I gave a talk living on master, and everything was Git submodule based, right? So I know how to use Git too, right? Okay.
Yeah.
So I'm patiently waiting for some stuff to land and be, flushed out and everything, right? My intent is to take things like bit-bake layers, layer index fetch, and add a dash submodule to that. So it will now, do that is with submodules, right? My intent is also to put that into the setup layers setup process, so that one of your options would be to do submodules. But I don't want to muddy the water with the design and everything that's happening now. I'm going to wait, and then I will do that. But I'm already working on my own tooling to make sure I know what the heck I need to know to make that ready.
Yeah, I mean, this is basically, if you want to see something happen, participate in the process. Don't complain after someone spent 6 months having discussions and then chime in with just one more step. Does anyone have anything else? Problems, questions? There are a lot of experts in the room.
Yeah, it's related to what you said about the Visual Studio plugin. For like new developers, it was really, really useful. Can onboard the developer from many background, and the thing it's always come up from my teams, it's hard to push to send patches upstream. Like the setup for new developer that's come from Windows, or they're not used to work with patches. It's like, oh no, I won't do that because it will take a night, but not a night, but an evening to set up, to configure mails and join the mailing list. So I don't know if they will have like a better way to contribute upstream, or it can be improved. Like for project like GitHub, you can just open a PR, and it's kind of make its way. I know it's not going to be like that, but for other project, it's really more friendly for new developer.
No. There are no forbidden topics. It is a controversial topic due to some workflows that are involved. And so first of all, my personal opinion is the project should not depend on proprietary software for workflows. I wear my open source hippie hat, but I know people have looked at GitLab, which kind of removes that objection. I will say that Chem is pretty good about watching pull requests against Meta OE or Meta Open Embedded. So some layers are definitely a lot more open to different workflows. Open embedded core is driving an auto builder cluster, and the workflow of those developers is very much driven by patches on mailing lists, unfortunately, and it would be somewhat challenging to convert to a pull request based. And Paul.
Yeah, I was just going to ask a poll of the audience, has anyone been involved in an open source project where they've used one of the recent sort of mailing list to web interface front ends, and has it been successful? Anyone?
B4? Are you talking about B4 and lore?
I mean, which part of the toolchain do you mean? Like for making it easier to send patches or to receive the patches and know if it's applied or this kind of thing?
Paul, use the microphone.
Yeah. Patchwork doesn't necessarily help you submit the patch, which is kind of what we're driving at.
Yeah.
But yeah, the whole workflow is important, I suppose. But I mean, for a lot of people, just getting or having to be signed up to the mailing list for part of the process is a problem. I mean, just being able to send email through the system that we have to deal with is horrible.
Yeah, sending patches via email is actually difficult. I mean, I'm good at it and I know how to do it, but I understand that it is pretty tricky. I mean, I think I use Gmail as a relay.
So we talked about this a lot in Prague also. We've been talking about it for years, right? But so, you know, we're not going to switch the project over to be pull request based or these kind of things, right? But that doesn't mean we can't do this. So what do? Enhance in parallel. So I have already done quite a bit of architect design on this particular thing, but it's just not, we didn't get all the tooling and everything ready yet, so it's not ready for me to open it up for more discussion, because more and more discussion is just more bike shedding. But I do have some very concrete ideas that can make this work and do absolutely nothing to disrupt the current workflow at all. It's literally enhance in parallel.
Yeah, I mean, workflows is a very sensitive issue. I mean, I'm sure it's come up in other projects, and the point you're making is, I mean, we hear it's just difficult to re-engineer an entire workflow. Yes? Oh.
Okay, I guess.
So, yeah, you go.
Okay.
And there's one person in front of you also with the microphone. You wait.
Okay, so I really appreciate all the work that has been done with CVEs. And I also observed that there are some projects, specifically I'm thinking of, that don't really seem to use the CVE database, don't seem to get assignments. And I'm just curious as to if there are, or if help is needed, or anything along getting some of these additional projects. Like, I think Rust crates, for example, is one thing I'm thinking about. Or other, like, I think there's also, like, what, OSV, potentially? I don't know. Like, I don't know. Like, I haven't been paying attention, sorry.
Supplemental database.
Yes, supplemental database.
Yes. In spite of wearing security flare, know very little about security other than the fact that these are very good questions. Do you know, Marta?
Wait until next week, okay?
Okay. Wait until next week. Hopefully that's a great answer. And does that cover your? Okay.
So sorry, it was back to the other subject about workflow. I think one of the big issues, of course, contributing can be a bit hard, especially in a company environment where you don't have a mail that can actually send stuff to you.
No.
But also following the patch. So as a drive-by contributor doing a patch eventually, it's kind of hard to follow where are you in the process without being monitoring the mailing list. Sorry.
Yep. So have you looked at like lore? It will let you basically give you filters, and you can kind of. I'm very sensitive to the mailing list problem because my mail provider spent a month Groups.io spent a month or so in SpamCop's blacklist on my mail provider, so I stopped getting project emails, and that was great. I mean, I was basically on vacation for most of that month. My mail flow dropped dramatically, and I'm like, this is life-changing, and I need to think about how I look at mailing lists. But it's kind of I totally understand the drive-by. We totally have a problem where you're at in the cycle of a patch. Patch test at least helps, because it is going to screen your patch ahead of time and tell you if there's anything stupid and mail you, the easy stuff for the reviewers. So you will, do you get a mail that says your patch worked?
No, and that's my question. Why don't we get that? I mean, for all the projects, the big open source projects, you are informed once your patch is accepted, but not for Yocto and not for BitBake.
I know. This is not the first time I've heard this. And this is going to come under the we are listening, and I think patch test definitely might say that send you an email saying your patch worked.
Yeah, that could maybe be like a conditional thing. Like if it succeeds, maybe just send an email to the author. But you can imagine if we had it reply with a positive to every single patch that was submitted, the mailing list would explode. So.
Yeah, I was thinking individually just to, hey, it passed patch test, now it's up to humans to merge, is a step in the right direction.
Actually, I was asking about just getting informed once it was accepted or applied.
Yeah, I know.
So then that I know when to update.
Yeah.
It was certainly the workflow we wanted to get to when we would, because some of this stuff has been going on for quite some time, and it's taken us a very long time to get to a point where, even where we are now. But yeah, we did want to have automated, when your thing gets into master next, so it's under test, and then again when it actually goes into master. And then those are points we can detect quite easily. But yeah, the automation is not there yet. But.
Well, it's not really it's kind of a question, but what we're discussing here is a lot of, we're discussing workflows, and then we are discussing different requirements, small toolings, extra toolings, and I think it might be worth, I'm not saying anything new, and I'm not saying that anybody is not thinking but the word is value add. I would prefer that Yocto projects spend as much as possible effort on what is actually a Yocto project. And there any time spent on tooling workflow is necessary evil, because we really should be making Yocto, which is embedded software. So when we spend time on creating bots, monitoring mailing lists, sending out mails, that might be necessary, but as Tim says, we will not be switching to pull request. That's an opinion, but the more we spend on custom tooling, you said it yourself in your talk that you were very happy that some things got removed. As time goes by, we should consider how much effort are we willing to put into our own custom tooling instead of going with something that already has a lot of stuff and then spend time on doing embedded software.
Yeah, I think, so let's kind of wrap up the tooling, because we're going to have 5 minutes, and I want to see if anyone else has questions, but I really like yours is we need to get the focus on building Linux distributions and delivering higher quality, covering more of these buzzwords in ways that our managers want. Basically we want management to like, hey, you have to use this Yocto project stuff because it checks off all these. And if you go and talk to your manager about workflows and emails and blah, 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 they're like, oh, what are you doing? You're not doing what I told you to do, which is deliver Linux distributions. So we have 5 minutes. Do we have any new topics?
Okay, this is a very naive question, but what is the
what drove the Sovereign Tech Fund to value Yocto? Because I mean, I've tried to get other projects through.
I'm going to tell you what I think, and I may or may not be right. But so apparently, someone in the German government realized they needed to spend money on some of this stuff that they depend on, and there was a trial run that they did that was very small. And around that time, Richard also had an article in LWN about the trials and the difficulties of a maintainer, where basically your user base has exploded. We have no idea how many devices running Linux built with the Yocto project there are in the wild. But, I mean, the room is pretty full here. And we get a lot of questions, and we see a lot of stuff, so we know there's a lot of people out there using it. And at the same time, I mean, I've said it before, is the Yocto project's measure of success is all the people I know that used to do a lot of like core support work now have full-time jobs for companies delivering product based on it. And what that has led to is Richard's workload going up, up, up. And so he wrote an article about this. And someone in the Sovereign Tech Fund circles saw this article and was like, oh, we should ask these guys, what they have, how we can help. And we happen to have a 5-year plan on hand that led to us being able to get some work spun up fairly quickly. That's my rough outline of the background as I understand it.
So I guess my obvious next thing is you need another 5-year plan to go back to them with.
Yes.
And that was your leading question
that was
at the
my
beginning.
Leading question.
So I don't know if we've gotten there with tooling. So what do you want to, what's the direction?
All these flags. I mean, I want to go back and look at Joshua Locke's talk on supply chain security and build systems and try and line up things that we don't have well covered, or at least have good, understand where we sit in supply chain security. I mean, we have SBOMs, but there's a lot of levels of, building secure Linux distributions. And I said that word to someone last night, and they said, what do you mean? And I don't know what I mean. Because there's a lot of aspects to that. And from my point of view, we started building Linux distributions for Sharp Zaruses, and now we're building Linux distributions for tractors and spacecraft and cars. And, we need to make sure that we're building what we said we were going to build, and that people cannot interfere with what we build, and that helps everyone. So a lot, you hear about security. Well, I don't care about security. Well, you do, because it will improve the ability for us to predictably build the software you want in your device.
Yocto is pretty unique in what it does, and I think it can solve a lot more problems than the embedded people think about on a regular basis.
I mean, so if you notice, I try to force myself to stop saying embedded Linux distributions. I say Linux distributions because, we've had talks about people building containers. Clearly, we're building for some very things that are hard to consider embedded. So it really has become a Swiss Army knife for building custom Linux distributions for all sorts of applications. One more question or answer.
Is that good about tooling or? This morning, I was not aware they dropped the kernel LTS to 2-year now support.
Yeah.
For the 6, and Yocto still have, I think LTS is 4-year, and LTS was like guaranteed to stay with the same major version kernel. So what will be the plan for that?
Do you remember what that is?
Okay. So I had another conversation with somebody else who was requesting each LTS go into ScarthGap, each LTS kernel go into ScarthGap. So that's a discussion that's going to happen. However, we did absolutely commit to, during the ScarthGap release, we will have a kernel update to a new LTS. I don't remember what we actually said we were committing to. I think it was midway, like at 2 years. But we have had one of our largest sponsors come and ask for every year, but they're asking actually for other sponsors to join in to fund that, right? Let's resource that so that that actually is totally doable. It's not Richard doing it. It's not Bruce Ashfield doing it, right? It's not one more of the some guy in Nebraska at the bottom of the XD comic. So yeah, anyway, we are absolutely going to be updating the kernel. Absolutely. And meanwhile, we've got mix-in layers for other things. So like I've already started a U-boot mix-in layer for ScarthGap because we absolutely have to have new U-boot in the modern world. There's too many devices coming out that need new things.
I mean, the summary there is LTS stuff is hard. The Yocto project LTS is our best effort. Clearly, the commercial aerospace guys plan on supporting this for 35 years, which I think is one of the great reasons to use the Yocto project is you can choose your life cycle. You know, you're not, some guy's not going to tell you 10 years. You're going to I can go to Wind River, for example, and buy support from them. And if I don't like them, I can take my build files, put them in-house, and support it for as long as I need to support it. And you're not dependent on any one vendor to give you your support for whatever time frame you need. And I'm now 2 minutes over. So thank you all for coming. Going to unplug. Oh. And if you have questions, catch some of us in the hallway.
It doesn't really make sense to have a 5-year plan, which is good.
I know. I think there's a members meeting next week, and I need to basically say we need a new 5-year plan. Thank you.
Can you hear me? Okay. Okay, so hello everyone. I'm Nadav from Autotalks. My original plans were to have this talk in person, but unfortunately I had to change my plans. So thank you for adjusting your schedule and joining this talk in its updated time slot. I'm super excited to be here. It's a real honor for me to speak at ZTS and take an active part in the Zephyr community. I would like to share with you today the journey we had in the last 2 years developing a SOC from scratch using Zephyr. Just a second. Yes, okay. Okay, so we will start with a short introduction, so you will have some background about the SOC as a product. Then we will talk about the SOC boot flow, the pre-silicon development phase, and list some additional features and challenges we had along the way. We will wrap up with a summary and some time for questions. Here is a list of terminology and abbreviation that I'm going to use during this talk. So SoC, System on a Chip, V2X, Vehicle to Everything, AP for Application Processor, EHSM for Embedded Hardware Security Module, SDR for Software Defined Radio, BL for bootloader, I or DCCM for instruction or data closely coupled memory that we have per AP core, and CSM, which is cluster shared memory, which is shared between the AP cores. Okay, so a little bit about me. I have a bachelor degree companies and joined Autotalks about 7 years ago. After about 2 years, I was offered the position of a software team leader. Today, I'm the software platform team leader, which develops the low-level code in our software hierarchy. The software platform team was the first team to shift from Autotalks Gen 2 to Gen 3 Zephyr-based SOC, developing the software parts in parallel to the SOC silicon development by the VLSI team. A little bit about Autotalks. Autotalks is not a typical startup company. It is almost 16 years old. It was founded in the early days of standardizing V2X technology. Autotalks is a multidisciplinary company with R&D teams in the fields of software, hardware, VLSI, RF, and algorithms. The vision of Autotalks is to have a world with no accident. Our mission is to develop the best V2X solution for the market needs. In Autotalks, we developed a V2X system on a chip. Autotalks' first product was FPGA-based and was aiming small-scale deployments, such as vehicles inside mines, where the number of vehicles is relatively small, but the vehicles are physically big. Having an accident inside a mine can be an expensive event. Our Gen 2 product was developed in cooperation with ST Microelectronics. It is ARM-based and runs Linux or ThreadX, depends on the selected architecture. It is already deployed in some regional projects, such as the European Sea Roads project, where it is deployed inside roadside units along the road. In another project in the US, it was deployed in the emergency vehicles and traffic lights in order to provide traffic lights priority to emergency vehicles on the way in cases of emergency. Switching the traffic light to green for the emergency vehicle to pass with minimal delays. It was also selected for several mass production OEM projects and will soon hit the roads. Our Gen 3 product, which is our focus here, is in an ongoing development. It was developed from scratch by our talented VLSI design and verification engineers. It is Synopsys ARC-based and runs Zephyr all along its boot flow, from its ROM to the V2X application. It was already selected to future deployment projects, including infrastructure, cars, and bikes. It was designed to have high performance and throughput to support advanced V2X use cases. Our SoC provides the very low access layer of the V2X stack. In some architecture, it also runs the V2X stack software itself up to the application layer. A little bit more about our Gen 3 Tecton SoC. It contains a dual-core Synopsys ARC HS48 application processor, a RISC-V core for the embedded hardware security module, and 3 CEVA DSP cores for the SDR. It has several peripheral interfaces such as UART, SDIO, Ethernet, SPI, QSPR for NOR and NAND flashes, a JTAG interface for debugging, Hyperbus interface for HyperRAM, and more. Internally, it has several memories, several crypto engines, and some proprietary IPs such as mailboxes and hardware semaphores for inter-process communication, timers, firewalls, and more. A little bit about V2X. V2X stands for Vehicle to Everything, with the main goal of preventing accidents and save lives. There are 2 standardized V2X technologies. One is DSRC, which is based on Wi-Fi 802.11 standard. The second is called CV2X and is cellular-based and uses direct link between the communicating parties. Our chip is the only V2X solution that supports both of the technologies. V2X as a radio-based sensor is the only non-line-of-sight sensor. It can identify a car bursting into an intersection on a red light, even if it is behind the corner or relatively far for a visual sensor to detect. In this picture, you can see several examples of V2X communication channels. V2X can be installed in vehicles, including motorcycles. It can be installed in infrastructure, such as traffic lights or roadside units along a highway. It can also be installed in vulnerable road users, such as bikes and scooters. There is currently no hardware V2X solution for pedestrians, but they can also be protected, for example, by integrating V2X with a camera, which can give V2X indication to drivers when pedestrians are in danger. In this picture, you can see some common V2X use cases, such as do not pass warning or intersection movement assist. Since V2X is not our focus, I just want to give you a glimpse of it. The fastest and most intuitive way will be to show you some short videos. In this video, you can see the orange car turning left, the blue car approaching the intersection, but the driver can't see the orange car because of the car in the other lane. V2X as a non-line-of-sight sensor would detect the incoming collision and alert the drivers. This video is an example of a roadwork warning use case. The driver is not aware of the roadwork in front of him. When he does, it is too late to prevent a collision. In this case, roadside unit installed along roads or even just on the roadwork infrastructure itself could have alerted the driver in advance. I saved you the 2 last seconds when it really crashes. Okay, so this was the introduction, and now we will focus on the Tecton SOC, the SOC development. We will start with the SOC boot flow. The SOC boot flow starts from bootloader 0 of the application processor and EHSM cores. Both are implemented in ROM, in read-only memory. The application processor bootloader 0 sets the minimal must-have SOC configurations, such as clocks and resets, and continues by loading bootloader 1 of the AP and the EHSM firmware. Bootloader 1 expands the SOC configuration by initializing additional memories and drivers, initializing the SDR cores, and loading its firmware, and finish up by loading and executing the V2X application image. The V2X application image is where the V2X logic is implemented, communicated with both the SDR cores, the EGSM, and the external host using the V2X SDK. We will focus on the application processor, which is Synopsys ARC-based. Perhaps the trivial way would be to implement bootloader 0 as bare metal. By doing so, we would have full control over the software flow. No additional thread or OS scheduling was involved. What you code is what you get. Bootloader 1 could have been implemented as MCU boot, which is part of MCU Manager. MCU boot is a secure bootloader tool which is supported by Zephyr and is commonly used and tested. This way, we were leaving only the V2X application to be Zephyr-based. The path we took is a little bit different. When designing the SOC boot flow in light of the system requirements, we have decided to implement the whole SOC boot flow as Zephyr-based. This allows us to utilize the drivers existing in Zephyr, which are used by bootloader 0, bootloader 1, and the application. It also allows to implement the image loading related code and boot related function as libraries, such that both bootloaders can link with them. Although MCU boot supports secure boot, our secure boot design is very different and can be easily implemented based on MCU boot. Also, MCU boot does not support all the boot interfaces in our system requirements, which include UART, SDIO, Ethernet, and more. Why did we choose to develop our Gen 3 SoC using Zephyr? As I said before, our Gen 2 SoC was Linux-based. Our developers are already well familiar with Linux concepts, such as device tree and kconfigs, which are also present in Zephyr. Zephyr is a rich environment in terms of supported drivers, features, the Z-test environment, and more. Z-test is modular and highly configurable OS. We saw that we can use it all along the boot flow, each stage of the boot flow with its own configuration and footprint limitation. We also conducted some benchmark of context switch and other OS-related functionalities and found that Zephyr is the best choice for our demanding performance requirements. Zephyr is an open source project. There are no secrets or behind-the-scenes functionalities. Also, there is a growing community and places to be looking for answers, such as GitHub, the Zephyr mailing list, and Discord. Also, Synopsys is one of the initiators of the Zephyr project. It has contributors of its own and can support us if needed. A little bit about the source tree structure that we used. Zephyr published an example application repository to be used as a reference of how to develop Zephyr-based applications. In this example, the Zephyr source tree is being expanded by adding out-of-tree applications, drivers, libraries, and so on. We like the concept of having Zephyr modules, being able to keep the Zephyr OS code tree clean and add all of our SoC additions in a dedicated repository. We have 3 software teams. Each implements a different layer in our software solution. We wanted to be able to separate the development into several repositories. Each handles its own logic. One of them is used to expand the Zephyr OS tree with our SoC, boards, drivers, and any non-V2X related code. Another one contains all the V2X specific logic, such as libraries, high-level drivers, V2X SDK, and more. When needed, we added or modified code in Zephyr OS repository itself under a dedicated ifdef for easy identification of our modifications. This assists us when upgrading Zephyr to a newer version. We can keep track of our additions and make sure they still hold for the new version. An example of such an addition is in the arc-reset.s core file. We needed to add SoC configuration in the very early boot stages, such as PLL configurations and hardware deassertions. Okay, let's talk about the pre-silicon development phase. The pre-silicon development phase is very challenging. The hardware is not there for you to develop your software. The hardware itself is also under development, so when something is not working as expected, the issue can be either in hardware or software. In the pre-silicon development stage, we had several development environments to work with. Each has its own pros and cons. We had a hardware emulator, which is slower than the real SoC, but quicker than the hardware simulator. It supports some peripheral interfaces such as UART and Ethernet, unlike the pure software simulator. Its main disadvantage is that it is not fully emulating the real SoC, meaning that code that configures the clocks is not being tested, or since it's not sensitive to uninitialized Z values, it will not detect related bugs. The hardware simulator is very slow. Simulating 1 millisecond of execution takes about 1 hour. Simulation of our boot flow, where several images are being loaded, can take between several hours to days. It doesn't have peripheral interfaces, but it is sensitive to clock configuration and Z values, which make it more real SoC accurate. Both the hardware and software simulators allows view into the SoC digital waves and a JTAG interface for debugging. The software simulator is much faster. It runs on x86, allows quick debug cycles, but it is not simulating any hardware, so it can be used only for pure software debugging. Here is a screenshot taken from the hardware simulator. The hardware emulator gives the same view. We can see here, for example, the digital waves of the QSPI lines, which are connected to QSPI NOR flash. We can also see the CPU clock, the CPU PC register, and more. This allows us to debug complex bugs, which are hard or impossible to debug using JTAG. Sometimes when the VLSI team is chasing a bug, the software is just a tool for tracking down the root cause of the hardware bug. Using the digital waves, we can figure out if the issue is with one of the QSPI lines, if it's a bus error, or if it's something with the command being sent from the QSPI controller to the flash. We can also know what is the PC register value when the issue occurs. Using the code disassembly, we can figure out which function is the one triggering the issue. I will show some additional SoC features that we developed. Secure boot flow. As I said before, our SoC integrates an embedded hardware security module, or EHSM in short. The EHSM is the root of trust of the system. It has the ability to authenticate, sign, and decrypt the images being loaded along the boot flow. In this diagram, we can see the boot flow over time. The SoC boot flow starts from bootloader 0 of the AP and the EHSM cores implemented in ROM. The EHSM allows loading the EHSM firmware only, as seen in the green line. The motivation is to keep the EGSM bootloader 0 logic to the minimum and expand the EGSM abilities in a loadable and changeable EGSM firmware, which allows loading all the rest of the images as seen in the blue lines. Every image being loaded by the AP bootloader 0 or bootloader 1 is being passed through the EGSM. Only after a successful authentication and decryption, this image will be processed by the AP core. Switching between the AP images is done by either a reset or a direct jump to the next image. Another feature that we implemented is the ability to utilize high-performance instruction memory implemented in ROM, in a read-only memory. In our SoC, we have several memories. The memory with the highest performance is the ICCM, the instruction closely coupled memory. We have both ICCM RAM and ICCM ROM. Bootloader 0, for example, is implemented as ICCM ROM. We have some ICCM RAM space, but it would be nice to have some more. The chip designers didn't like the idea of adding some more RAM, but ROM is cheaper in terms of silicon area, so it was suggested as an alternative. As you can see, 1 megabyte of RAM and 3.5 megabyte of ROM equals the same silicon area. How can we utilize the ICCM ROM? We can put in there pieces of code that do not tend to be changed and are also frequently used. For example, we have implemented in assembly a very efficient memset and memcopy functions. Those are relatively simple functions which do not tend to be changed and are frequently used. Another benefit in the reduction is reduction of cache pollution. Since the ICCM ROM is not cached, if, for example, we are running our application code from the CSM, the cluster shared memory, which is behind cached, and the cache is already full, calling uncached function will cause some cache lines to be invalidated. Instead, if we frequently use functions are, instead if the frequently used functions are in a non-cached memory, such as ICCM ROM, it will not affect the cache and can send some cache misses. Here you can see an example of the symbol table of the code that goes into the ICCM ROM. All the functions are defined as weak functions, such that they can be overridden by the application that links it. There are several test functions that can be used for debugging and testing the ability of overriding weak functions. There are also the memset and memcopy functions implemented in several variations to be most efficient. For example, memcopy of a dword aligned source or destination can be implemented very efficiently without the need of taking care of alignment or fringes. The best way we have found to implement it using the ArcMetaware toolchain is to compile the ICCM ROM content as ELF file. In the CMake of the application, we added the Zephyr LD options command, which tells the linker that there are additional symbols to be linked with. This allows the application to call those functions, even though the functions are not compiled as part of the application itself, but present in the ICCM ROM. Here you can see a made-up example application code. The function oprom atlac memcopy is implemented as part of the application, such that it overrides the one placed in the ICCM ROM. Using the ability, we can replace the ICCM ROM functions in case a bug was found or if the function logic should be updated for a reason. Calling the memset application will trigger execution from the first ICCM ROM. Calling the memcopy function will trigger execution from the locally implemented memcopy function. Another feature that we implemented is to utilize high-performance memories to contain frequently used code and data. We have several memories available internally and externally from our SOC with varying performance. Some are behind L1 cache, L2 cache or not cached at all. The IND CCM, for example, the instruction and data closely coupled memory, are the fastest, uncached and also uncached memories. The HyperRAM is the slowest and is L2 cached. The code contains functions which are rarely used, such as initialization functions being called only once at any time. On the other hand, there are frequently used code, such as the V2X RxPath code, which can get rates of 4K packets per second. The V2X TXPath code is in between, with rate of 10 packets per second on average. The frequently used code and data can be placed in a relatively high-performance memory. This is a future feature. We did not start its detailed design or implementation. We can assume that we will have to do some linkage magic here in order to map functions to specific sections, depending on the function usage and memory performance. This will allow us to improve the overall performance of our SoC and support the demanding throughputs of advanced V2X use cases. Okay, let me detail some bugs and challenges that we had along the way. Okay, so the Zephyr Arc reset and start bug. This bug was found when we moved from using the hardware emulator to the hardware simulator. Code that ran with no issues on the hardware emulator got stuck in very early reset stages on the hardware simulator. As noted before, the hardware emulator is not sensitive to Z values. Z values can happen, for example, when the hardware has no defined reset value and the software is not taking care of setting any init value. When we discovered this issue, we started debugging it using the digital waves, first with our VLSI team and later with Synopsys support. In the debug session, we have found that the Arc reset and start function is missing code that initializes all the Arc core registers, R0, R1, R2. Synopsys is an active partner in the Zephyr community and has several contributors who confirm the issue and push the fix into the Zephyr codebase. Another bug is Synopsys Arc cache invalidation bug that we have found. As described earlier, we have several memories in our SoC. Some of the memories are behind L1 cache and some are behind L2 cache. The Synopsys Arc CPU subsystem provides a way to control the caches, for example, to lock cache line such that they will not be spontaneously invalidated, flush or invalidate the whole cache, or a specific region of the cache. While developing a unit test that stresses the memories by reading, writing, and verifying the data, we encountered an issue where at some scenarios the data being verified is not as expected. Our test was developed to our random accesses at random addresses, alignment, and size. While debugging the issue, we found out that the issue occurs when the data is inside a single cache line, meaning that it's smaller than a cache line, and both the start and end addresses are within a single cache line. We added Synopsys support to our debugging efforts. After validating that we are using the cache APIs correctly, they checked their hardware side implementation and found out that there is indeed a bug in the API. In case the range is within a single cache line, the operation is being translated to 0 lines to be invalidated, and hence the data remains valid in the cache. Later on, Synopsys publicly announced the bug with a fixed version. This example is not a bug, but a software challenge that we had to deal with. In the Synopsys Arc memories architecture, there is an option to have a shared memory area that can be either cluster shared memory or L2 cache. For example, 2 MB of shared memory can be defined by software to be either 2 MB of CSM, 2 MB of L2 cache, or split between CSM and L2 cache. The challenge here was that the shared memory reset default is L2 cache. during our boot flow, we use the CSM as the destination memory for our images. Our secure boot flow requires us to have a CPU reset in between images, but the memory region where the image is placed at becomes L2 cache, and the image can be executed. Luckily, we have a small private CSM, which is not part of the shared memory, and it is always CSM, even after reset. The solution was to link the image such that the reset and start function and other early stage code that is executed before configuring the shared memory as CSM is linked to the private CSM memory. Okay, let's summarize. Okay, so Tecton SOC, the Tecton SoC was developed from scratch using Zephyr. Zephyr runs all through our boot flow, from the ROM to the application. We already had 2 SoC tapeouts. The third is expected in the next few days. Our first official version with a real SDR is about to be released soon. And when deployed, Zephyr will be in the core of a life-saving product. That's it from my side. So if you have any questions, this is the time.
Does anybody have any questions? I think we're good.
Okay, so thank you for joining this talk.
Thank you.
If you have any additional questions, you're welcome to contact me on Discord.